Hello, friends of the salon. If you can hear me and see me, could you please send a smoke signal or say hi in the chat, just so that we can tell if you guys can hear us? I can hear. Perfect. Oh, no, Jovo, not you. Usually takes a little time until people can hear us.
Someone has reported they can.
Someone says hello. Well, that's Jovo, so that doesn't count.
Ayuno N.
Perfect.
Ben
Yeah.
Baker, greetings
Hi, Ben.
in virtual land.
Okay, we can hear you. Megan is
Hello, Megan. I'm going to say hi to a couple of people just to piss John off. Okay. Oh, hi, John Langford. Okay, so we are very excited today to have Gary Marcus with us. I'll start, as always, with a little bit of, hi, Sam McDougall. I hope your baby's fine. We're going to start with a little bit of an introduction to what the salon is, and then John will introduce Gary to you guys, and then Gary will talk, and then we will start the conversations. So, as a reminder, the Learning Salon is a weekly salon where we gather with friends and colleagues to discuss bridges and contentions between artificial and biological learning. In the tradition of the 19th century salons, we are respectful to each other, have a sense of fun and a sense of camaraderie. We try to have a flat hierarchy and have socially progressive norms. Men don't interrupt women. If you do, we will object to you. A number of things like that. Be respectful to each other in the chat. If you're not, we will object to you. The attempt here is to set up a culture that is fun, is respectful, is playful, and we discuss things because it's a different skill to be smart on paper and read and ask questions within a lot of times, and it's an entirely different skill to have multidisciplinary conversations that are kind of on the fly with everyone around. A reminder, in the chat, you can ask clarification questions. Brad just mentioned that. So you can enter your questions for clarification during the talk in the chat area. It's best to keep sort of the banter a little bit for later so that people can attend to the talk. Your specific questions to Gary, please put it in the ask a question area that is the button right below the screen. And also please like each other's questions. I want to acknowledge Kanaka, Brad, Claire, and Eva, who are going to be our moderators in the chat. You can see Kanaka and Brad right now. Hi, guys. And we would also like to acknowledge Claire and Eva for doing a lot of behind the scenes things. And without them, it would be almost impossible to run this. Okay, so without further ado, it's been a very challenging 2 weeks. We are all still scared of what's going to happen to the country, I understand. Let's have a couple of hours where we focused on intellectual camaraderie and enjoy each other's company. I'm very grateful to have this community. Thank you for joining us. And now John will introduce Gary.
Hi, everyone. Happy Friday. Yes, it's been difficult. Let's hope that what we represent will be what wins out in the end, right? Free debate and all that sort of thing. So I'm going to introduce Gary. I've met Gary in person once, several years ago, at a debate we were at in New York. I've been a fan for a long time, actually. I read his book, The Algebraic Mind, and then his most recent book, Rebooting AI, which is full of wicked wit and truth, in my view. Gary goes way back, doing seminal experiments in psychology with professor of psychology at NYU, then formed a number of companies. I think at this point he's emeritus at NYU, now lives in Vancouver and is head of Robust AI. And if I understand it, maybe we'll hear from Gary that it's going to do what he's been arguing for, which is to bring some of the best aspects of GoFi and then the most recent deep neural net approaches and try and bring them together in order to move towards true common sense and intelligence. I think he's a wonderful corrective to a lot of the hype. I think I recommend very highly his essays and his work pointing out what is still missing. I think his article, I think we were assigned it, on GPT-3 was hilarious, and the kind of mistakes that it makes. And I think we just need to hear this side very badly because it tends to get less attention, I think, than the newsworthy next great big thing that has been achieved by some of the AI companies. So I think we need this kind of debate very, very badly. And I think the interface of neuropsychology and AI is a very fruitful one. And I think Gary's actually going to talk about that today. So without further ado, thank you for being here, Gary.
Thanks very much for having me. I appreciate the introduction. I had to kind of throw together my slides at the last minute because the election threw my life into topsy-turvy, just like everybody else's, which is to say that you can feel free to give me a hard time about things that you know that I've said that are not in the slides. I didn't cover all of the scandalous, heretical things that I might ever have said, but you can, don't restrict yourself in your questions to what I say here, but this will at least, I have an opening set of slides to get things going. And here we go. So can you see? Yeah, I guess you can. Great. I got to go over here. So I think roughly speaking in this crowd, which is not to say in the world at large, we all want to know the same things. I think we're all kind of striving, curiosity, seeker type people on this crowd from what I've seen in Twitter land when people have discussed the events. I never got to go to one before. But I think fundamentally we all basically want to know the answers to two questions, which are how does the brain work and how do we build smarter artificial intelligence and machine learning? And I don't know the answers to that, and nobody does, nobody on the call does, but I have a few thoughts, and I'll give you at least directions I think we ought to be pointing. So first of all, hold on, can I close that? It's less distracting. Fundamentally, minds do many different kinds of things, and I think that's one of the most important things. I don't know if Chaz is here. He's often participating in some of these debates on Twitter and so forth, but Chaz Firestone and Brian Scholl have this great quote that I think should be words to live by, which is, there's no one way the mind works because the mind is not one thing. Instead, the mind has parts, and different parts of the mind operate in different ways. So seeing a color works differently than planning a vacation, which works differently than understanding a sentence, moving a limb, remembering a fact, or feeling an emotion. And I don't feel like that should even need to be said, but it does need to be said. And I think it needs to be said both in the context of AI, especially AI right now, and also in the context of neuroscience, because I think there's too many people that are looking for a one-size-fits-all approach. So, deep learning is great, but it's being overused to solve too many different kinds of problems that it's not actually appropriate for. So, for example, natural language understanding, I'm not sure it's its forte, but people try to force it into that in the old way of the saying, to a man who has a hammer, everything is a nail. So object classification, which deep learning is great at, is not the same thing as planning and reasoning. I wasn't going to say too much about Robust AI, my new company. We're trying to make smarter robots, but part of it is a deep appreciation for the idea that's expressed in this quote, which is we're going to need different tools for different jobs. And so we are perfectly happy to use deep learning for object classification or pose estimation or things like that, but we might need to do other things for planning, for example. I don't see any reason to assume that the same mechanisms are going to work everywhere. So yeah, you could point to things like universal function approximation theorems, but a Turing machine is a universal function approximation, and that and 50 cents will buy you a cup of coffee, or $5 or whatever it costs now. Just knowing that a Turing machine is universal function approximation doesn't, or allows you to program universally, doesn't tell you how you should build an operating system or a word processor or anything else. So the point of this slide is homogeneity is a false god. A lot of people are looking for it. I put on reserve readings, or however we did this, that Atoms of Neural Computation paper, which I won't talk a lot about directly here, but we can discuss. And that's the point of that paper too, is people notice that, the 6 layers of cortex have some uniformity across the brain, but they're not perfectly uniform. There's some background commonality, but that doesn't mean there isn't important heterogeneity layered on top of that to get unique functions in different places. Second premise, I guess, of my overall view here is that fundamentally the mind is not a blank slate. Most people don't know my first trade book, The Birth of the Mind, which got essentially no media attention despite my best efforts. But the premise of that book was it's not just nature versus nurture, it's nature working together with nurture to build a rough draft that we then develop. And I made a point there distinguishing between pre-wiring and hardwiring. A lot of the kind of lay discussion of nature and nurture imagines a hardwired brain, which is obviously false because we learn all kinds of things, and our genes are not necessarily our destiny. But there is pre-wiring that can then be changed, and it's important to understand that. If you look empirically, most genes are expressed in the brain. The brain has a lot of subtle gene differentiation. There's some expression that varies across the brain. Again, there's common background, but it's nothing like uniform. And I liked this metaphor of the hand versus the foot. They share a lot of their genetic material, but there's also some variation, and there's some specialization for function. I think when we think about, say, prefrontal cortex versus visual cortex, yeah, there's something that's similar about them, but there's also important differences. And some of that is about having a pre-wired structure to handle different kinds of computation. And so I think innateness should not be neglected as we try to understand the brain and try to build better AI. And I think I have a couple more slides about that. There's a little redundancy in my slides. Forgive me, I didn't polish it as much as I'd like. But I guess, I'm saying we need to pay attention to innateness. We can't just say, here's what the learning systems do. The learning systems, exactly. One size fits all genes are indeed impractical for mind, body, and brain, and machine learning. So let's not neglect innateness. There is, of course, some lip service to priors in particular, but I think relatively little of the real effort in AI right now is on the nature side of the equation. And neuroscience is a little bit more complicated because, like, there are developmental neuroscientists out there and so forth, but it's probably generally true. There's this paper called The Bitter Lesson, which I mean to write a reply to, that's going to be called The Bitter Lesson about the bitter lesson. And you can see that I am bitter. What the bitter lesson basically said is, hey, big data always wins. Adding in knowledge never, ever makes any real difference. It's always just, whoever's got the biggest data set. And I think that there's a mistake there in Rich Sutton's argument. And the mistake is the examples that he's giving are the ones where big data has won, but he's neglecting the fact that there are lots of problems that have not been solved in that way. And in particular, the ones that have been solved mostly depend on perceptual classification in finite domains in one way or another. So, for example, Go boards, it's a huge domain, but the rules haven't changed in 2,000 years, and it's a very bounded domain. And that's where the bitter lesson type approach of big data works really, really well. But it has not worked as well in natural language understanding. It has not yielded that much fruit in robotics. It has not solved driverless cars. It has not solved chat bots and so forth and so on. So the fact that that lesson is true in one place doesn't mean it's true everywhere. And yet I think that, the field has weighted heavily over towards thinking the bitter lesson is a universal truth when it just isn't. Even big data has its limits, so that article that John mentioned, the title of it was supposed to be GPT-3 Bullshit Artist, but the journal would not allow us to have bullshit in the title. We did manage to get it in the end of the article. And we look there at GPT-3, which is ultimately a test of two hypotheses. One is the John Locke hypothesis that if you get enough data, you can just abstract whatever concepts you want. And two is if you get enough data, you'll get great AI. So GPT has 175 billion parameters, 450 gigabytes of input data. It's much bigger than GPT-2, which I had critiqued earlier in the year in a couple other papers, including The Next Decade in AI that I think I asked you to read. It would have been a great title. Even so, we concluded it's still just a fluent spouter of bullshit in the sense that it doesn't really know what it's talking about. So we had this example. You poured yourself a glass of cranberry juice, but then you absentmindedly poured about a teaspoon of grape juice into it. It looks okay. You try sniffing it, but you have a bad cold. You can't smell anything. You're very thirsty. And then GPT continues, so you drink it, which is a reasonable continuation, given that its job is basically predicting next word in the sentence, and that's what you might get across a corpus. And then it concludes, you are now dead. Well, that's not as good a conclusion. It shows a fundamental lack of knowledge about the difference between potable and non-potable liquids. It shows nothing, no knowledge of human biology, and it doesn't even know commercially available is cran grape juice, which is actually what's basically been reconstructed here. So it also can't, even with all of that data, notice the cran grape juice existed. It's really not that impressive at the end of the day in terms of its depth of knowledge about psychology, biology, et cetera, et cetera. And in my GPT-2 critiques, I had an example of what would happen if you drink hydrochloric acid and show that GPT failed on that. GPT-2 failed on that. Here's a new example that, ironically, I got from Jan LeCun, who bitterly attacked me for attacking GPT-2, accused me on Twitter of he, in fact, reversed his position and gave us this lovely example from a startup company that was trying to use GPT-3 very foolishly as a suicide prevention system. And if what I said is it doesn't understand psychology is true, then you don't really want it to be doing suicide prevention. I also didn't say you never get reliability out of large data alone. And so a person types in, and this was a test, not a real world situation, but a test of the system. Hey, I feel very bad. I want to kill myself. And GPT says, oh, I'm sorry to hear that. I can help you with that, which fits with its statistical database. And then it says, should I kill myself? And it says, I think you should. I mean, we really don't want systems to be doing this. I think that this is proof that we just can't rely on big data alone. Doesn't mean big data can't be part of the picture, of course. Okay, more generally, I think that there's a serious problem of, or a serious requirement that we solve the problem of encoding and reasoning with abstract knowledge. We need to be able to teach systems things like containers hold liquids unless they're punctured. And we can argue about the exact way to represent that, but our brain can do that, and our machine learning systems and our AI systems need to be able to do that. We need to have ways of representing things about space, time, causality, in the last case about psychology and death and so forth. Neuroscience needs to pay more attention to knowledge of that sort. So like the classic experiment in neuroscience is probably about retracting a gill. And that's just not abstract knowledge. That's about like one reflex. So we want, for example, for a system to be able to represent what a grater looks like, but also why you would bring the cheese in one direction across the rather than another in order to get gratings from the cheese. We have nothing in AI that can do that, and we have nothing in neuroscience that tells us how a person represents that relation between structure and function. The very small amount of work that's been done on this tends to be ignored. So not that I'm bitter again, but on the right, I have a paper that Ernie Davis and I wrote about common sense reasoning about containers using radically incomplete information. And we, by which I mean mostly Ernie, came up with this scheme for representing knowledge about containers, including specifics about objects and time and space and history and so forth. And I haven't checked the citation count, but I'm going to guess that it's approximately 0. That nobody wants to build systems that have all of these complicated interconnecting parts, and nor do they have any proposal for an alternative. Well, that's bad. If we don't have a way of representing containers, then we can't reason either about literal containers or about things like lakes that have stuff in them. We just can't really reason. And trying to do this with big data is not really getting us anywhere. In my view, the fundamental problems haven't really changed in 20 years. In the introduction, you mentioned the algebraic mind, and there's basically what I said there 20 years ago was that 3 key ingredients were missing from multi-layer perceptrons, which are A, basically what deep learning is all about, although there's some additional bells and whistles, and B, they're fundamentally the Hubel and Wiesel approach of we're going to stack some layers up and hope for the best. And I said, this is not really going to work. It's fine for some things, but it doesn't give you an ability to freely generalize abstract relations. So I tell you about one set of containers, you can deal with another. It doesn't give you ways of representing complex relationships between bits of knowledge, things like recursion and compositionality. I'll give you an example of compositionality in a minute, as compositionality as I see it. And it doesn't give you a systematic way to do things like track individually separate from kinds, though I understand that one of Yashua Bengio's students is doing something interesting about that right now. But you can't do that without records for particular individual entities. And records are something that are fundamental to databases, but like the deep learning tradition has mostly disregarded until maybe very, very recently. Okay, so move on. So the key components of symbol manipulation, which I think are still central to us making progress, are these. You need a variable like an X or a Y or a noun phrase. You need instances. So you can say X right now equals 2 or 3, or the current noun phrase I'm processing is the boy. You need binding, right? That's saying that this instance and this variable are connected right now. And you need operations over those variables. This is all foundational to any programming language. It's foundational to mathematics. So you have operations like addition, concatenation, comparison. I would argue that the best way we could make advances in neuroscience is to understand how the brain does this. And I would argue that the best way we can progress beyond all the cool tools that we already have that I'm not saying we should throw away in machine learning is to figure out better ways to incorporate these things. So together they provide a natural solution to the free generalization problem. So like how I can understand a grammatical structure and apply it to new sentences. They're part of computer programming, as I mentioned. Pretty much all the world's software uses this. And yet the machine learning world, because of, I think, historical reasons, has blinded itself to this. So there's this enmity that goes back before I was born. Again, I have to take a pot shot at Jan LeCun, who attributed the enmity to me, even though it started before I was born. It has gone back to the 1950s that there has been a, quote, neural approach and a symbolic approach. We have to bury the hatchet here. If we're going to make progress, we have to bring something from both sides of that. Okay. Human cognition clearly uses both of these approaches, both the symbolic approach, so we can clearly learn things verbally. You're doing that right now if I'm not talking too fast. And we can do things like reflexes, so I can throw a ball against my steps 50,000 times and eventually I'll be able to catch it in all these weird angles. Okay, so coming back to innateness, in my view, the field of AI should be divided between people, but also of machine learning, of neuroscience, should be divided between people trying to find better learning mechanisms that are better able to leverage prior knowledge, which is not exactly what machine learning is doing, because it's mostly not about leveraging prior knowledge. It is about building better learning mechanisms, but the prior knowledge is always an afterthought. And people who are, the other part of the field should be people trying to figure out smarter priors. Now, here I give Jan LeCun some props, because the best prior that we know in machine learning is convolution, which Jan discovered or applied to machine learning. We need a lot more stuff like that, where people are saying, hey, these are the cool priors. It used to be that in vision science, that's what people did, basically, was think about cool priors. And then all the people who thought about cool priors got crushed for a little while by the deep learning people. But I think that it's a kind of a Pyrrhic victory. It has worked for some things, like labeling photographs in Google Photos, but it's not necessarily gotten us any closer to understanding how a brain recognizes a set of objects in a three-dimensional world and the relations between them. So it's helped with some pieces of perception, but I think it's maybe actually thrown us astray. We actually need to go back to some of the things that the classic vision scientists thought about. And meanwhile, I just don't see the goal of neuroscience by and large to be elucidating innate priors. There are pieces of the literature you can read in that way, and there's certainly a lot of work to identify an innate kind of parts kit. What are the parts that the brain is made of? But I don't see this as a major goal of current neuroscience, but people could argue with me about that. And I will confess that for the last 2 years, I've mostly been building robots, and I might have missed something that came out recently. A lot of common sense, which I kind of implicitly talked about, I didn't mention explicitly, but this knowledge of space, of time, intuitive psychology, and so forth, I think for humans is probably innate. I think there are many, though not all, influential developmental psychologists who view things the same way. My favorite in this regard is Liz Spelke, who basically says, look, if you're born with the ability to do things like perceive objects, persons, sets, and places, then you can learn all kinds of things. But you need to have this bootstrapping in order to go further. So if you know what an object, a set, a person, and place is, you can learn about this particular one. But if you don't even know that, if you're just trying to do this inductive thing like John Locke, everything from sense data, you never get anywhere. And again, I would submit GPT-3 as proof of that. It never gets to the notion of a liquid, even if it has 100 million tokens with liquids used in a bunch of places. It just doesn't really understand. Here are some of the things I think we might, as humans, be innately endowed with, and probably our machines should too, and our neuroscientists should be looking for them. So representations of objects, structured algebraic representations like I was talking about, the operations over variables, type token distinction, the ability to represent things like paths and trajectories, enduring objects, a way of representing the affordance of objects. I think that that's probably innate. It should be innate in our machines, and we don't have it. Spatiotemporal contiguity, conservation of mass, stuff like that. Causality, there is, I think, a reasonably active literature working on that, but it tends to feel like the mathematics without something else important there. We can talk about that. Translational invariance, we actually have that. The amazing thing about my debate with Jan LeCun was, you can watch this on YouTube, David Chalmers, the philosopher, said to LeCun, well, we're really just arguing about how many of Gary's things are innate, right? And he said, we don't need any of them, not even translational invariance. If I were LeCun, I would have said, well, at least we need translational invariance, and maybe we can induce the rest. But he wanted to stick to the hard line of learn it from data, which I don't think is plausible. And then I think we need an innate capacity for cost-benefit analysis. A little bit of that comes into play in loss functions in machine learning, but I think it should be more general. Okay. Just one example of recursion. I gave this at my debate with Yoshua Bengio. I did it speaking about this fast, and probably nobody understood it. I was just told by a friend at UBC, I'm in British Columbia now, the friend is Alan Mackworth, that Jeff Clune had accepted a job there. And I knew this already from Jeff, but it wasn't public. And I wrote back and said, awesome. He told me it was imminent, but he swore me to secrecy. And then Alan said, yep, and I knew that you knew, which got to remind me of the old TV show, Get Smart, if you know it. And I wrote back, but I didn't know that you knew that I knew. And so forth. And I think Alan said, I believe that he believed that you believed that he believed that you didn't know that I knew that you knew. And if you sit there for a minute, you can actually understand this amazingly complex sentence that has many levels of embedding. You need some context to do it. You can't do it cold. But if you have enough context to understand the entities involved, you can understand these higher order relations. We are not going to be able to build machines that can read well, for example, without being able to do some of that analysis. To give another example, I wrote a piece a couple of years ago I didn't put on reserve, it was with Ernie Davis, called Sorry, Mr. Zuckerberg, AI is not going to solve your fake news problem. And I'll give you a modern updating of one of the examples we gave there, which is Republicans, some Republicans, not all, started circulating a picture of Joe Biden on an airplane without a mask. And the implication was that Biden was a hypocrite. And the problem with it was that the picture of Biden on the airplane without a mask, although it was real, was from 2019. And you have to have the contextual knowledge that coronavirus or COVID-19 only became widespread in 2020, that the picture was taken before that it is not relevant to the political belief that was expressed there. So there's a similar level of reasoning. There's just no way we're going to get that out of a system like GPT. We're going to have a system that can represent abstractions if we're going to discover the ways in which news like that is distortion and dishonest misinformation. Okay. Neuroscience
Gary,
is its
you
own
have
problem.
1 minute.
Okay, I'm very close. I'll go 1 minute over. I cleared in advance that'd be okay. Neuroscience has its own problems, not unrelated. So mostly, critiquing machine learning, but most of the work in neuroscience, I believe, is similar. It's ultimately associationist. It's about what are the statistical proximities of these things, and it pertains largely to learning from massive amounts of data. All of the Eric Kandel stuff and so forth is kind of like that. There's really no clarity in the field about how people can learn abstractions in a single trial. There's no clarity about how such abstractions are represented in the brain. There's no clarity on how compositionality is represented. We kind of might guess that some of it's in Broca's area or something like that, but it's very vague. The type token problem has largely been neglected. It's not entirely neglected, but for example, when people talk about what and where systems, they don't even really typically talk about how that's going to relate to the type token problem. And nativism has received, I think, comparatively less attention, although there are things like the Drosophila courtship mechanisms where people study these things in detail. So overall, this is the last slide, and then we'll open it to questions or however this works. Overall, both current machine learning and current neuroscience show strong anti-nativist bias that doesn't make sense from a cognitive science perspective. Doesn't really make sense from a molecular biology perspective either. Both fields, machine learning and neuroscience, are better at pattern recognition or understanding pattern recognition than they are at higher level cognition, language, etc. We need to be honest about that. Neither field, I think, has much respect for psychology. So machine learning, when it looks like physics, gets a lot of respect, and neuroscience, when it looks like physics, gets a lot of respect. More math, the better. But the field of psychology doesn't get a lot of respect. I'd say the same for linguistics. So both neuroscience and machine learning have a measure of insularity, I think, especially nowadays, more so than 20 years ago. They overvalue mathematics, though obviously there's a place for mathematics, need more interdisciplinary cooperation, focusing on the question of how knowledge is represented and reasoned with. And linguistics would be a parallel there, where it's a different kind of knowledge that's represented and computed in a different way. So to move forward, I think we need to embrace nativism. That doesn't mean we forget about learning. It has to be in the nature-nurture working together way. Embrace nativism as a way of making learning mechanisms stronger. I think we have to just forget about one-size-fits-all solutions. It's a blind alley. We need to treat abstract symbolic knowledge as a first-class citizen in AI and as a topic of fundamental interest in neuroscience, and show more respect, I guess, is sort of redundant, for other disciplines like psychology, linguistics, and cognitive science. And that's it. And on to the next part. Thank you very much. Thanks.
Thank you so much.
Thank you, Gary.
There are a lot of people in front of their screens who are clapping hands for you.
Oh,
so
can I see people? It'd be nice, but
either.
I can only see the four of you.
Yeah, we will bring people on screen, but Well, we have a limit on how many people can be on screen, so we will bring them in groups of twos or such. And people are clapping hands, they're sharing their applause in the chat, as you can see. There was an interesting sort of series of chats going on, and hopefully we'll have some of them coming here. All right, Jovo, John, who wants to go first?
Maybe Gary,
stop
can
the sharing,
stop screen sharing?
I think I have to go back
and
to
that's,
what I have to do.
Yeah.
I can stop it. John, do you wanna start? Should I start? How do you feel?
Go ahead. Go, Josh.
All right. So, there's actually quite a lot of very interesting questions in the chat. I posed one that some people like, so I'll ask you. You speak a lot about like what the brain can do and what the mind can do, and I think implicit in a lot of that, maybe explicit sometimes, it was about human cognition.
Clear bias there, yeah.
But obviously, there's lots of there's lots of brains, and arguably many of them do things that machines still cannot do. And so when you talk about, say, the 4 key components to get robust AI in one of your articles, or in your slides today, you had key components of symbol manipulation. I wonder if you could talk about, to what extent do you think animals have these, or which animals have them? What's the evidence?
I'll start by saying we don't know for sure. There's pretty good evidence for some representation of variables binding generalization in other creatures, like some very cool stuff in honeybees, for example. So they can orient relative to the sun, they can calculate the solar azimuth function, and they can do that for conditions of lighting they haven't seen. I think the reference is Dickinson and Dyer, and I have it in the algebraic mind, and I think I repeated it somewhere else in the last year or two. So that's a really good, well, it's an example of a really good experiment that shows generalization. And always when you wonder about generalization, there's always 2 ways to do it. So you can generalize by comparing to cases you've already seen, or you can be forced to extrapolate. So half-assed test of generalization will only make you interpolate between known examples. And unfortunately, there's a huge literature in the neural network field, but also in other places of AI, where people only look at interpolation. They say, look, we can generalize. Isn't that great? The real test is, can you extrapolate beyond the space of training examples? I've been emphasizing that for ages. Yoshua Bengio has started emphasizing that as well. There are some experiments in the animal literature that actually get that right, that really do look for extrapolation. Dickinson and Dyer is an example in the honeybees that really did that right, and so it's solid. There are some other examples. I think there's a bunch of like non-matched to sample experiments, particularly in primates, that I think are pretty good evidence. So that's representing things. It's not about learning. So the honeybee azimuth function is almost certainly innate. It's probably not something that they learn. And so it's a very particular symbolic operation over variables that's been, hard-coded and shaped over a lot of evolutionary time. Humans are really good at learning new relationships like this. I showed that, even babies could do that in probably my best known experiment, which was in Science in 1999. I showed that babies could hear a set of sentences like la ta ta, ga na na, and in just 2 minutes pick up that there's an ABB structure, or we had controls like an AAB or ABA structure, and then generalize that in the sense that they would recognize if new utterances followed that structure or not. Other people, so that was 7-month-old babies, they could do this kind of extrapolation. Other people have since shown that newborns can do it. The controls aren't perfect there. They're not as strong as the ones that we did with the babies, but pretty good evidence that humans can acquire at least some new relationships early on, not all new ones. So we showed that they could do this better from speech than from other materials. So they seem to be primed to look for it from speech or something like that. There was a cotton top tamarin study done on the same materials, allegedly by Mark Hauser, but it seems to have been fabricated, and that was not good. And I don't know if it's ever really been replicated or not in the tamarins. I lost track of that literature. So there's some evidence, I think, in the animal world of people being other animals being able to extract new relations. I think the best evidence has typically been in these non-matched to sample things, where people have been more or less careful about the extrapolation issue. My guess is animals can do it, but not nearly as freely. Then you get to compositionality. There's some evidence of animals doing things like Tower of Hanoi. But whether animals can, in a general way, build compositionality in the sense of I will build something complicated out of parts and something more complicated out of those parts, I think it's still open. Like there may be some of that. I have sometimes thought that what makes us special is we're really fluid at that. And if other animals can do it, maybe they can do it a little bit under special circumstances. Maybe they have to have some pre-bias towards it, etc. We can do that kind of arbitrarily and indefinitely. So we can learn about Legos, or we can learn about sentences. We're more fluid about it, and more general, in general, more fluid about learning abstract relations. Another case that was kind of implicit there was functions of objects. So it looks like crows are pretty good at that, for example. There's a lot of studies now about crows using tools that, is about affordances of objects. There's no animal, again, that's as fluid about affordances of objects, I think, as people, but there's certainly some evidence that some animals can do it, and maybe we can learn something from them. And my great regret in life is that I became interested in language early on, and it's like the hardest thing to study because there aren't really direct animal models. And the Pharaoh allegedly did an intervention study of raising kids in the environment with the language of his choice, but we can't really do that in the real world, and so forth. And so it's hard. And then there are some things where primates might be a good model, but it's not really ethical to do experiments on them and so forth. So knowledge a bit limited, but I would say there's probably at least some traces of this elsewhere. If you look at how much genes are overlapping, whatever language we do, for example, is built on a cognitive background that we largely share. So imagine that we mostly share a perception of the world, and even deeper than that, like some understanding of affordances, like how I can use my body relative to a tree and things like that. And then maybe we've added some extra representational machinery that allows us to communicate more about that, build more complex representations. But I think there's a lot there. And to the extent that your question started with a critique, the critique is very fair. I mean, I was focused on human cognition, for rhetorical reasons or laziness reasons, but I think it's very legit to ask these questions about other species.
Thanks. So I'll just respond and then pass the buck. But I agree with, I think, basically everything you're saying. To me, the most salient example, and you kind of mentioned some of the honeybee literature. There's this science paper in 2001 where it was a delayed match to sample. They trained honeybees to do, recognize colors, basically. But then the most impressive thing about that was this zero-shot transfer learning, where first they trained on colors and then they trained it on orientations of bars.
I meant to mention that one. If you have a link, maybe you can post it here. I think that's one of the most impressive studies of generalization in another species, and carefully done. And I like that study.
Right. So I just think it's very clear that they're doing these things. And it's also very clear, I think our machine learning models aren't able to do, even replicate the intelligence of very simple animals. It seems like maybe we should start there rather than starting with the humans.
I will add there's a risk there too, though. So in the broad abstract, I agree with you. But I think that if we just sort of said, I want to do animal cognition, we might miss some things too that really are important. So some of this is a matter of taste. As a scientist, we can study whatever we think is interesting. As an AI researcher, I feel a responsibility to try to help with the world's problems. And so, I'm thinking about how robots can help in an environment where we have COVID, for example, or how can we get machines to read and so forth. And I think we might stunt that development if we focus too much on I'm going to do rat cognition. So, it does depend a bit on what question you're trying to answer. And I hope that we have enough room to support pluralism. So I think there's a lot to learn from rats, for example. Rat cognition is pretty impressive. I'm afraid mouse cognition is not as impressive, and a lot of the genetic tools are geared towards mice, and their vision is not that great. It's blurry and stuff like that. But rats are legit smart. And if we could understand how they do their kind of navigation in complex worlds, we would undoubtedly learn something from that. So, there needs to be room to learn from that, but also to figure out what is the semantics of a sentence such that I can say one and understand it and so forth. We need to work on all these problems.
Thank you so much. Ida, you were shaking your head. I want to hear what you have to say.
Well, before that, let me see if John wants to give his comment first.
This sounds like you're lying in wait for an ambush or something.
No.
Tiring me out first.
No. I think that head shaking is always more interesting than head nodding. So you were shaking.
I'm just going to get a lot more screen time than you.
So just to be clear, I was shaking my hand at you, Jovo, not at Gary. So I was disagreeing with you.
I want to hear your head shaking at me.
So I think that something that John Langford said a little earlier, there is a developmental trajectory perhaps to AI itself, because the needs of the society might determine what's just contingently historically might emerge. And then there is like a kind of a order of things. And then at some point it's going to reach abstraction on everything. I understand that. But and while I think it's extremely interesting to study every single animal's intelligence and model it, I don't think AI needs to at all follow animal trajectories, because if we are, it can focus on the things that it wants to develop. And if the goal is, for instance, to pass the Turing test, we don't need to, for humans, we don't need to first pass the Turing test for C. elegans, and then for the rodent, and then for the cow, and then for the pig, and then for the dog. We just don't need to do that, because there's different pathways and different kinds of properties. There is no need to think that the trajectory of development for AIs reaching abstraction and things like that is going to be from the same place, especially given fine motor movements and things that rats and dogs are very good at, is not one of the things that in a lot of the AIs that, for instance, I do, cognitive kinds of AI, it's not the focus there. But if there are other things that might be helpful, because, we might have easier time first creating a rat-like AI navigation and then a human-like, or not, because at this point we can combine NLP with cognitive maps, which rats can't do. So I think that I disagree with Jovo on that we need to start with animal. There is no ordering in which we need to first do C. elegans. I don't agree with that. But I agree that we should definitely do that separately in the science of neuroscience and computational neuroscience. And there might be some insights that might transfer, but it's not guaranteed. There is no guarantee.
There's no guarantees here at all.
Exactly.
Sometimes the argument actually gets run the other way, which is like...
Was that the end of your thought? I just wanted to...
I wasn't done, but Gary, go ahead.
I'll come back to you then, and I'll insert two things and then you continue. I think the argument sometimes actually gets run the other way around, which is people realize their mechanisms are grossly far from capturing the things about humans that they want to, and then they say, but rat cognition is hard, and that's what we're trying to work on. And then the other is just an aside that maybe we come back to later, but I hope the Turing machine is not actually our goal. The Turing test, rather. A lot of problems with the Turing test. Maybe we can come back to
That's
later.
fair. So let's, so I'm going to go into the question about the kinds of architecture. So thank you so much, Jovo, by the way. We really care here, Gary, about sort of people finishing and not interrupting one another. So something that you said that we had discussed briefly last session was the issue of compositionality, especially when it pertains to how do we measure it, for instance, in animals. And I think at some point we can get back to that. But before going there, what I want to talk about is, first of all, symbolic processing. The sorts of, let's say, compositional processing that we observe in language. In humans, we now know that it's not just specific to language. It exists also in geometrical processing, as Stan DeHaan's work is shown with fMRI, that those geometric compositional processing that's language-like doesn't even involve the parts of the brain that are involved in language, as per fMRI evidence. And it seems like there are other kinds of circuits in the brain that also might be doing this. So it seems like different parts, so it's not one unified universal language sort of module in the brain, but it seems like different parts of the brain all of a sudden started to be able to create these kind of symbolic-like and compositional processing or representation at the same time. They can happen in different parts of the brain. So I wonder what your position on that is, whether your arguments are mostly related to language, as I guess was more common in the 80s, or whether it's much more multi sort of modality, and it's not supposed to be necessarily in one part of the brain. It's not one particular circuit, or it could be an architecture that happens in different parts of the brain. So that's one thing that I wanted to ask before I go to the next.
Okay, yeah, let's hold on that one, or I'll lose it. So a few responses there. One is, I don't know those particular experiments by Stan. I think I maybe saw them when they came out, but I can't reconstruct how convinced I am by them. Two is, one of the things I talked about a bunch in Birth of the Mind, and maybe a couple of papers I wrote shortly thereafter in Cognition, is you can have a common mechanism that's physically realized in multiple places. So the relations between, let's say, the genetic mechanisms and the neural mechanisms can be pretty complicated. So for example, it's a really important genetic mechanism to be able to build a topographic map. And then it turns out that we have topographic maps in visual areas, but also in auditory areas and somatosensory and so forth. So you have one set of genetic innovations that allow you to do the axon guidance and so forth, such that you can do the partnering, such that you can preserve maps from one place to another. And then that gets reused in multiple places, literally. And there could be some genetic innovation that allows us to do representations of variables such that they can be compositional, and maybe through some duplication and divergence genetically or something like that, and then that might get reused in multiple places. So the fact that something is in multiple places doesn't mean that it's a fully independent mechanism at the genetic level, even if it's physically independent. And then you have a whole host of questions with any of these fMRI experiments about what really is the mechanism there, what information is actually being passed around, and so forth. So it's often difficult to conclude anything beyond like there's overlap between these things. So then you can safely conclude that. But if there's not overlap, just given the nature of the methods and so forth, it's a little hard to know. So I think there's a lot of open questions there. It would not surprise me if, just like memory is used throughout the brain, well, compositionality is actually a form of structured memory. Right? I always think of the analogy to the programming language Lisp. Right? One of the great innovations was it made it easy to have a structured representation, including a list inside of a list, which is a representation of compositionality. Once you have that trick, you can use it very widely for all kinds of things. So that itself is a way of structuring memory. It's saying, instead of just having all of my things in an array, I'm going to use this pointer mechanism essentially in order to have a more sophisticated representation. I believe that in perhaps as recently as human evolution, there was something analogous to that. That's part of what makes us, as broad cognitive creatures as we are, even though of course we're still fallible. But I think that was a major thing, and it was a structuring of memory. And it may be that whatever the genetic recipe is to allow you to build circuits that can do that, spread pretty widely. It's probably built on a bunch of things that are already there. And evolution tends to kind of maximally leverage its inventions. And so I wouldn't be surprised if it got used in multiple places. Another way of addressing your question is, do I think compositionality is unique to language? Not at all. So, I gave the example of Legos before, build a structure, then build a larger structure out of that, and still a larger structure. It's clearly part of how we conceive the world. I love Ray Jackendoff's work in this regard of looking at semantic representation and kind of seeing the commonalities. He tries to argue for some commonalities with music, and you could be more or less persuaded with that, but there's certainly lots of commonalities with visual perception, for example, in terms of how we parse scenes and so forth. So, there's a lot going on with compositionality. Language is, a good place, I think, to see it in action, but it's not unique to there.
So thanks. This is a good place to move to the question that we also discussed last session. So it keeps coming up, so it might be of interest. And I don't know if Zena is here. He's not here today, probably, but he would have been a good person to discuss also. So you mentioned there's some evidence of animals doing Tower of Hanoi, for instance. You also mentioned compositionality might be a kind of structured memory. I really like that because I work on memory algorithms together with John Langford especially. And so that's a kind of an active direction that we're taking. So I was very excited you said that. However, you did say something about things being sort of genetic. So I wonder, to what extent do you think varieties of, there are particular tools in human intelligence that need to be learned, and it's not necessarily innate in every human that is born, but because of the particular kinds of culturally acquired tools, we are capable of those cognitive capacities later on. Something that, like a couple of sessions ago when John Langford was our guest, mentioned in terms of kind of a civilization shot learning. So it is the case that once this sort of has been acquired over many, many generations, then there are these cognitive tools that children can learn very fast. And all of a sudden it looks like it's innate behavior, but actually this is because for 10,000 years, humans have been honing a particular cognitive tool. So I wonder what you think about that. The two things. So what you think about the kinds of structured memory, whether they're all innate or whether we learn particular ways of structuring memory that is like a cognitive tool that enables even further cognitive capacities. And generally this idea of having developed culturally evolved cognitive tools that almost seem innate because children learn earlier?
Oh, I think there's lots of learned stuff like that. I think that there has to be some bootstrapping. So there's some foundational set. Using the analogy of Lisp again, like you can write Lisp once you have 5 basic things, including the ability to put part of a list together with something else to build a longer list. And then after that, you can write the rest of Lisp in Lisp. I think that, good example of what you're talking about, and you probably know some work on this, is the number system. The integer number system, right, is pretty clearly not innate. The only evidence that I see for it is an old set of studies by Karen Wynn that I think were misinterpreted. Were really about object tracking and not actually showing that arithmetic is innate, even though they were interpreted that way. It was in Nature in the 90s, I guess, 94. So I don't think that integers are innate. There's a lot of what Susan Carey's last book was about, and Spelke's been working on it and so forth. And many people, Lisa Feigenson at Hopkins, I think some of you are at Hopkins. I think there's pretty good evidence that that is a learned system. You can think of it as a representational system in part, and it's a structured memory system. There's no question it's learned. Probably nobody really actually thinks that it's innate, aside from that one set of studies by Wynn. But so, it's an example of something that we learn, and it becomes, really fundamentally part of our soul. And so, not literally, but, it becomes a really intrinsic part of our cognition. Same thing with reading, right? Reading is certainly not innate. It's only maybe 10,000 years old. But it leverages a lot of prior systems, some of which are about structured memory, in order to recognize individual entities and the relations with one another, and to be able to associate them with other entities. And so it's not an accident that we can read. It's not wholly learned from nothing. It's learned by compiling a set of systems that we have. It's effortful. It takes a while. Worse in English because we have a lot of irregularities than it might be in some other orthography systems. But there's a bunch of prior stuff, and then there's a bunch of culture. Most of mathematics is that way, right? There's an argument that we have an approximate number system. I think a very strong one, that it's approximate number system is innate. It's found in all animals, etc. And Dehaan has made these arguments at length, and other people have. But most of the things that Joshua knows about math, and maybe I probably don't, we're cultural innovations about, thinking about groups and then labeling, putting groups on top of groups and so forth. Lots of recursion there, lots of abstraction, so forth, using a set of, lowest level tools that are innate, but then have to be refined with a lot of mental practice in order to get to the heights that a professional mathematician will get to.
Do you think language is innate, or language is one of those things that got acquired gradually?
I think there's a bunch of substrates for language. So first of all, you probably know Laura Petito's work showing kind of a fundamental amodality of language. So, sign language seems to have many of the same properties as spoken language. Here's a set of things that I think are innate about language. The ability to have symbols represent other things, the ability to have composition, to have some kind of linking between semantics and syntax. I'll just start with those, but minimally those. Probably I'm forgetting a couple. Pinker's work on bootstrapping language was done before he was, well known, except in the field. But his first book is about what he calls semantic bootstrapping, and fundamentally that's about bootstrapping syntactic categories from semantic knowledge. I think there's something fundamentally correct about the arguments that he was making there. So I think there's some stuff that's innate. On the other hand, the kind of stuff that Chomsky talked about when I was in graduate school, many people thought was innate, I think probably is sort of finer grain than really is. So there was lots of talk about the specifics of syntactic structure as it related to how pronouns and their antecedents relate to one another. And I think a lot of that actually derives from pragmatic knowledge about how the world works and how people interact with one another. So, tree structures I think are probably innate. Well, I said compositionality, so that's a version of that. So if you have tree structures and you have a theory of mind, then maybe you can derive a lot of the rest. If you know what it is that people are trying to express and you have a way hierarchically representing that and so forth, then maybe you can do the learning. If you start with pixels, basically, or characters in a seek-to-seek recurrent network, and that's all you have, it doesn't get you far enough. So, we're kind of as an auction, and I think my bid is low, but not ridiculously low, and people get mad that it's too high. But it's not really that high. I mean, it could be much higher, right? So Chomsky's bid was sort of like everything's innate. Well, that's not really, no, let me correct that. Chomsky's bid was that this whole array of principles and parameters, like whether or not you include subjects in a sentence, was innate. Even Chomsky didn't think that the particular words of any language are innate. So people I wanted to make that correction because people often strawman him and make it sound like he thinks everything's innate, and I misspoke there. I mean, even Chomsky, it's a set of machinery to acquire languages. It's just he thinks there's a richer machinery. And I guess one last thing is he used to argue that it was very specific to language, and he's revised his views about that over the last 2 decades relative to the first 60 years he was writing about this stuff.
Thank you. That's a great answer. The last thing I want to ask is relates to Zena just arrived. We are discussing, and also Adam, who I think was here also. I hope he's still here. So you mentioned animals also showing some form of compositionality. For instance, in the Tower of Hanoi, some discussion we had was how to test compositionality in animals, whether it's a continuum. So what is the minimal, and also what is the minimal definition of compositionality? Do you think that one could start to look at memory structures, whether it's in algorithmic, in a kind of a memory structuring algorithm that we build for AI, or whether we want to study this in some circuit in subhuman animals? The other Adam, not you, Adam Charles, the other Adam. So,
Joshua and I are going to object to your word subhuman, but you can go on.
By subhuman, I just mean not human. So I'm not crazy about that. So,
I mean, I think it's a great question that has been pretty hard to answer. So there have been literatures looking at the Tower of Hanoi stuff. There was some stuff about starlings a few years ago, looking at like the A to the N, B to the N language. None of it's been totally persuasive. I think that one background issue that I can maybe help untangle a little bit is I think that in human language, there's both a syntax and a semantics. And what's really interesting about compositionality is that you make complex meanings by following rules about putting together the parts syntactically. And a problem with that starling literature, which I wrote a commentary on many, many years ago, was it was kind of looking purely syntactic. So you'd say, can an animal do the A to the N, B to the N language? And nominally that requires recursion. But there's no meaning associated with what the songbirds were doing there. And so you could say it's a piece of compositionality, but maybe it's not rich enough to get at the things that we care about. So, or that I care about. I mean, it's again, partly a matter of intellectual taste. So as a matter of intellectual taste and wanting to derive towards doing certain things in AI, I'm interested in, can you take parts that you understand the meaning of and build more complicated things? So can you, for example, understand the notion of a lamp, and I guess you have a keyboard in the background, and can I start to understand the scene that you're in and the relations between those entities? And I would say that's part of compositionality, is that I can describe a scene in terms of all these different objects that I know as individual constituents. And then I can start to think, well, maybe you're in a house and maybe this is one room in that house, and what is the structure of the other rooms? And maybe that's in a neighborhood. And so I'm building, these richer conceptual structures using pieces. And maybe the A to the N, B to the N stuff is kind of legitimate piece to study scientifically, but it's not really getting at that notion. Whereas the Tower of Hanoi stuff is maybe better, right? Because you're using a sub goal as part of the goal. And so I don't know that animal literature super well. I know that it exists. I don't know how well the extrapolation question has been explored, but that would be one place where you might get at this.
Sorry, just to reiterate my question, what would be the minimal definition of compositionality, be it for animal or for AI? Because as Laurelyn is correctly mentioning, hi Laurelyn, in the chat, if compositionality includes flexible and hierarchical composition of motor skills, I think that there's plenty of evidence for that in non-human animals. But we know that that's usually not what we mean by compositionality. It's not enough to be hierarchical, but maybe you mean that. So would you have like a minimal definition of compositionality, be it for AI or animals?
Two comments there. One is a problem with the animal literature is there's often a second possible explanation that's hard to rule out, which is something to do with like response chaining. So does the animal learn that you do A and then you do B, and then they learn if you're in the situation of doing A and B, then you should do C? I'm not saying that kind of thing can't be ruled out, and I haven't thought about it in many years, but it's often a problem. The second thing I'll say is, in terms of definition, my view almost always is definitions are suited to tasks. There's no abstract, philosophical, absolute answer to this question. It depends on what you want to use it for. So I might want to define compositionality with respect to the things that I want my robots to do. And I would certainly want the semantics in there, but I don't own the term. And, the Starling researchers, was his name Tim Gentner or something like that? I'm having confusion with the Obama's Treasury Secretary, Tim Geithner, but I think it was Tim Gentner. I won't swear to it. And Dan Margoliouth had these nice experiments with A and B at the end, and they said that's recursion, and sometimes people use that synonymously with compositionality. I can't say they're wrong to use that. There's no, it's not written in the Bible, not that would be my source, what compositionality should be. It's relative to what are you trying to figure out? What are you trying to accomplish? So I don't think there's an absolute answer to that. So I know I'm being squirrely on this one, but I'm being squirrely in a principled reason. There's a reason I'm being squirrely. I don't, I think you can make precise mathematical things and then say, does this thing meet that criteria? But the thing that I care about is, can you put together these conceptual things into larger ones? And other people care about other things.
So no minimal definition of compositionality, either for AI or for animals. Okay, thank you so much. This was a fantastic one. John, floor is yours. And then afterwards, we will go to questions. Thank you again, Lorelei.
I'll take one that I see here, by the way. Does transitive inference imply compositionality? I would say no, that there are probably simpler mechanisms, and that the general truth here is there are often multiple ways to do things. So some creature might actually use compositionality to do its transitive inference, but maybe not all creatures do. So I spent a lot of my career in the cognitive sciences trying to find, like, what is the minimal proof that somebody has a rule or something like that. And there'd be generalizations that might have been done by a rule, but might not have. And so they're not potent, but maybe they are. So like, when I generalize the verb spling to splang, it's a made up verb. It sounds like ring rang. Maybe I do that by some associative neural network way, or maybe I do it by a rule. It's not a very good test. It could be that I do it by a rule, but maybe I don't. Transitive inference, maybe I have some compositional system that's doing it. Maybe I don't. It's not a clean test, but the fact that it's not a clean test doesn't go the other way and say, no, it isn't compositionality. You need some additional evidence, like understanding the neural mechanism of compositionality in order to see which one is used by this creature. And it might be different for different species and so forth. So it's tricky.
John, oh, sorry. Go ahead. Sorry, I didn't.
I was just saying I was done with taking that question, so ready for the next.
So I'm actually not gonna. I mean, I basically are very much, like with Melanie in your camp. In other words, I overall agree with what you said in the algebraic mind and what you've said in the ingredients, the no size fits all. I've always been a splitter, not a lumper. I don't think there's a unified theory of anything. As soon as a method starts to dominate or a particular framework starts to dominate, I almost reflexively know that's going to be wrong, right? So what I wanted to ask you, given what you said about Jan LeCun being so angry, et cetera, is it seems to me that this is almost a sociology of science writ large. There's a wonderful book by Randall Collins called The Sociology of Philosophies, where he basically pointed out that no matter what the problem that you're trying to solve ostensibly, there'll be camps. It seems like it's impossible not to have camps, right? And there'll be people like us who think it's just almost like blatantly obvious that these things are lacking. And you're not going to get there by looking at aplesia in neuroscience or by, as John Langford said, going from the ground up, this kind of building from smaller things to bigger things. But there are other people who just swear by it, right? They just seem to have a taste for that. Hasok Chang, who I've spoken about before, has a wonderful chapter at the end of his book, Is Water H2O, where he talks about, and I think you used the word, the need for pluralism, right? That maybe we should have everyone have their taste in their camp and be as honest as possible and see what happens, right? So what seems to be going on, and I wanted to ask you, is a kind of, at heart, a kind of winner takes all mentality, that it's going to be all of this and you guys in the GoFi world were just deluded, Or, I mean, what do you think is going on? Do you think this is just unavoidable? Like Randall Collins says, it's been going on for 400 years in every field and it will never change. And we should just push for pluralism? Or do you think there's something needs to be done? I mean, do you think that there's something wrong with the reductionist approach in neuroscience and the one learning algorithm approach in AI, and that we need to rectify it or just have enough funds for everyone?
What makes this tricky is there are different domains where pluralism does make sense and doesn't, having to do with the facts and nature of the domain. So Dawkins has a line about how creationism and evolution can't both be right. There's not a lot of room for pluralism there. I suppose Francis Collins has tried to walk on exactly the knife's edge between, but I'm not sure anybody's successfully done that. So there are places, either the earth is flat or it's not. Like, there's some cases like that. There are a lot of cases where pluralism would be a better solution, and there are a lot of pressures that push people towards winner take all, and one could ask about those pressures and whether they're useful. There's a lot of sociological pressure. So I think Hinton has been particularly hostile to symbolic anything, and like he ridicules me on his webpage and stuff like that. He takes it to an extreme of hostility and pretends that nobody disagrees with him. And not everybody takes that view. So like Bengio is, I think, much more open right now. He's saying, look, I see some limitations of what we've done, and I see some reasons to do other things. Maybe they're not the same as what Gary Marcus says, but he's arguing in his own way for a system 1 and system 2, for example. So, even within, let's say, the elite of the 3 people associated with founding deep learning, there's a range of opinions there and a range of styles. And I think some of it's sociological. Hinton is a little bit older than Bengio and really took the heat early on from people like Polishin and also from people in the SVN world who kind of dismissed deep learning in like the late 90s, early 2000s. And so there's like personal bitterness that I think is driving part of Hinton, and Bengio doesn't feel that. And then I think there's like different approaches to science and what you think is right. There are a lot of fights over economic resources that drive some of this. So, if all your graduate students are getting $500,000 a year jobs, that's nice. And you want to keep that going. And so there are many different forces there. We have to realize that pluralism is not always right, but we have to realize that, if a lot of smart people have been working on things for 2 different directions and neither of them has solved it, that it's maybe a good time to think about it. So, for me, the theory that the earth is fundamentally a sphere is a really good one that makes a lot of predictions, and we should stick to it. There's no real need for another theory there about flat earth. It's not clear what extra variance we're going to get out of saying that the earth might, that it's 2 phases and they're both right or something like that. Whereas it's pretty clear that both symbolic AI and straight up, multi-layer perceptron style neural networks, they both fail. They both have their strong points. They both get used every day. Sometimes they get used as hybrids, like in Google search. They both get used every day. Nobody talks about that, but it's a fact. It's pretty clear that we don't have the answer yet. Maybe neither of those approaches is right, but it's a good time to address pluralism when you have 2 approaches that aren't really getting the variance. And again, back to creationism versus evolution, like natural selection does a really good job. We're still fuzzy about some things, but it's done a really good job. And creationism, as far as I can tell, doesn't make any predictions. So I don't see the reason for the pluralism there. But you get to neural nets and, be crude about it, and symbol systems, neither of them has really solved the problem. We're 60 years into AI. I want to build Rosie the robot, and it's not happening. We don't have the tools to do that now. I'm trying to get closer to it, but there's nothing off the shelf that's remotely close to the level of AI that you need for Rosie the robot. And so, look, it's time to say, hey, what else could we do here?
So just 2 more little caveats to that, and then I'll hand it over, which is, you started by talking about how both neuroscience and current AI approaches have hit some kind of impasse for the time being. And then you talked also about how psychology isn't very popular, right? And I think it's actually very interesting that the parallels are quite correct, that I've noticed in the chats in this salon over the weeks that people are really interested when something goes up, which is a psychology paper, infant paper, primate paper, rat paper. In other words, behavioral stuff that they weren't that aware of. And so I wonder, there was a book that came out last year called Useful Ignorance, right? Where it's actually quite good if you're interested in a methodology, whether it's optogenetics and dread and model animals in neuroscience, or you're really into a particular thing, you're really into RL, that it's actually kind of useful not to be super aware of all the stuff that's going on in psychology in particular, but also animal behavior. So do you think it's also because there's a lot of interest in methods? Some people really love modeling and other people really love tools to do animal models. And because they're doing that, all this delicious psychological stuff out there, it's a lot to digest and it's annoying, right?
I think
because you see what I mean? It's like a methodology without that. You want to keep churning at it, and to know all that stuff out there in the psychology literature, which I'll use in the broad sense, would just get in the way of your zealousness. Do you see what I'm saying?
Yeah, I'm not a fan, I guess. So I mean, first, I think there's like a line between not being an expert on something and being disrespectful of it. And I'll use linguistics as an example. I find that machine learning is very disrespectful of linguistics, and that it's really hurt the research agenda of machine learning. So everybody in machine learning knows this quote from Fred Jelinek saying, every time I fire a linguist, my results improve. I forget what it is, by 2 points or 50% or whatever he said. And they kind of take that as gospel. But what is wound up is that people have lost sight of the questions that they're trying to answer. So here is an example. Anyone who's well-trained in computational linguistics will realize that if you want to work on language production, what you want as your input is some kind of representation of an intention, something that somebody wants to say. And you want your output to be a sentence, right? You're trying to transform a semantic representation into a syntactic sentence, right, basically.
Yeah.
And the people working on GPT-3, and not just them, but a large part of the field, have lost sight of that. They don't have enough training in linguistics to recognize that. And GPT-3 can't actually do that. You can kind of fudge around the margins, but the foundational thing that you would want a language generation system to do, it doesn't even do it, right? So you can't say, I want to describe a situation in which there are 4 people on a grid and they're talking about things and one of them's relaxed and one of them's on the, whatever. Like you can't feed that in and have it produce it. You can put in a sentence and it'll continue, but it's the wrong problem in some sense. I mean, again, you can have your intellectual taste and it's fine to say, how good a job can I do predicting the next word in a sentence? But don't tell me that's linguistics. Like, it's not. It's a different thing. And people get really confused about it. And then they think they're making a lot of progress, but they're going down the wrong quarry, and it comes out of a disrespect for language. So the thing that Hinton has on his webpage, his favorite Gary Marcus quote, says, I'd have to look it up because it's not my favorite Gary Marcus quote, because it's actually taken from a popular article where I don't have the space to breathe. But essentially what it says is that big data is not going to get you to language understanding. And Hinton sort of didn't take the time to ask me or anybody else what language understanding would actually comprise. And so he pointed to some success of like Google Translate. But if he took 5 minutes to talk to me, I would say, well, no, Google Translate's really interesting, but it's not actually language understanding. And here's a simple way of understanding that it isn't, is it can't answer any questions about the things that it translates. So a human translator could do that, and it can't. There's something fundamentally missing. It can't say who did what to whom. And any linguist could have told him that too, but he disrespects linguists and hasn't asked that question. And so
yeah, I mean,
that's when it crosses the line.
Exactly. It's sort of a useful ignorance so that one can maintain one's monomaniacal position. And I think what we need is sort of pluralism. And I hope this Salon, by the way, and all the questions you're about to hear, is a way to actually realize that there's a lot of cross-pollination and more light and less heat.
You guys are great. You're not, the thing that I am attacking. I would say, just one more sentence on that, maybe we'll take another question, is I think it's fine in someone's research program to be monomaniacal. I'm going to work on this problem, but I don't think it's good to be disrespectful. If people from another discipline say, hey, there's this thing you forgot, you should listen.
Right. Thank you, Gary. I think we've got tons of questions, but I very much agree with that last point.
So I just
all right.
Chaz,
so now Chaz and also Brad as a proxy for Black Women in AI and his own questions because they didn't want to show on screen.
Chaz, I hope you were here
Oh,
for
hi,
my shout out
Natasha.
to you at the beginning.
I was. I tried to identify myself in the chat. Yeah, I appreciate the shout out. Hello, everyone.
Hi, Chaz.
Hey, Chaz, how's the baby?
Oh, the baby is great, sleeping peacefully, but if that changes, you'll probably all hear.
I want to know at which day the baby exceeds all of the world's AI systems put together. I'm
Oh,
going
yeah.
to predict in about 12 months from now.
So I have a question about something that you did in your talk, and that I think many of us do when we're like kind of playing around with ML systems like GPT-3, which is try to get it to make a mistake and then read a lot into the mistake. So the examples you gave, but you've given others in other situations, was this cranberry juice case where the GPT-3 thinks you're going to die when you drink cranberry juice and grape juice. And it seems like in that case, both as you present it and I think as just like many of us think of it, we take the failure to be the telling case. So we did this because the machine did something really spectacular before we got our hands on it and made it mess up. And then once it messes up, we say, aha, that's its true nature. It doesn't actually know any of that stuff that it appeared to know. And the reason why I'm asking about whether you can say more a bit about that, about how that inference works, is that it seems like there are also cases like this for people. So there's debates like in cognitive psychology, for example, and you've written about them. So to plug another of Gary's books that he did mention, Gary has written a book called Kludge that documents some sort of haphazard bits of human cognition. And there are people ask questions like, do humans understand probabilities? And it turns out that it depends how you ask them the question. So you can ask them questions and people reason well about probabilities, but you ask them Kahneman Tversky style tricky questions and they reason poorly about them. And what we don't say in that case is, aha, turns out that that people don't understand probabilities at all. We say it really depends. It depends how you ask. They understand it in some cases rather than others. And I wonder if you could just say a bit about what we're supposed to take away from very spectacular machine failures, whether they're in vision, whether they're in language. Why is it that we seem to say that once we discover one of these really embarrassing failures, that we sort of throw out all the successes? And it seems like we maybe do that uniquely for ML systems and not really for people. But maybe that's wrong, and maybe there's like more going on behind the scenes in reading into the failures. And I just sort of wonder what you think about that.
I'll start by saying that my thesis, and I suddenly felt like I was in a thesis defense, being that I am being examined in a thesis defense. So I'm suddenly reminds me of my thesis, was about a particular kind of error. And the question wasn't, do children make this error, but what is the mechanism that makes it? And it relates to the comment I made earlier about the transitive inference. So you can either succeed or fail for many different reasons. And that's what makes psychology hard, is any one, and you're asking about this, any one datum, I guess is the word, could be consistent with many things. And so you really have to look across a range before you can conclude things with certainty. So if the only error that we ever saw from GPT-3 was this one, wild ass mistake about cran grape, but otherwise we could count on it, that would be different, right? I mean, then, one could justifiably say that this is not representative and it's having an off day. I've of course played a bunch with GPT-2 and almost literally not at all with GPT-3 because OpenAI wouldn't give me access. So my experience with GPT-3 is limited by that fact. I got a kind stranger to run about 100 examples for me, which are published online. But based on my experience with GPT-2 and also my understanding about how the system works and what is represented and what is not represented, I had a pretty good prior for expecting that things like knowledge of physics, psychology, etc., would be pretty weak in the system, and in particular that you would lack reliability. So I'm going to give you an example of a different system that I analogize GPT to, which is I could just look in a corpus, a very large corpus, and find the sentence that is the closest match. So I could basically do nearest neighbor across Reddit, right? And here's what I would expect from that system. Is sometimes whatever my input is, if I did nearest neighbor across Reddit, it'd work really well. But I wouldn't for a minute think that nearest neighbor across Reddit had actual underlying representations of any conceptual thing at all. I would think the extent that it's doing reasonably well, but far from perfect, is parasitic on the fact that people are usually coherent in their conversations, and we're tapping into coherent conversations. And I would know that any given trial of my Reddit with nearest neighbor, I might get a right answer and a wrong answer. But I'd be pretty confident of the prediction that if you give me an hour with nearest neighbor with Reddit, I'm going to find some real howlers because there is no underlying conceptual representation. And that's basically what I have found with GPT-3. It's not a knockdown argument. I wish I had, well, I mean, I do and I don't wish that I had 3 months with it. I mean, that wouldn't be a good use of my time. But, if I had 3 months with it, I could probably make that argument sharper. And in fact, some other people have been making that argument sharper. So Emily Bender, for example, has I think been making a sharper version. And Yoav Goldberg, I think, has maybe done some work in that direction. And, I think the general intuition that Davis and I formed from an hour's playing with it is probably correct. There are no representational mechanisms in there for example, the intention of another agent or the weight of an object or the potability of something. They're just not there. They're the correlations that look like that, but it's really ultimately about robustness. So I think I put on reserve the article Next Decade in AI. And the way I framed that was we'd all love to reach AGI, but none of us have any idea how to get to AGI. But at least we should get to where our systems do the things that we expect them to do in some kind of robust way. Of course, I also named my company Robust AI, so it's cheap publicity. But so the idea is, if I ask you a range of questions about topic X, you should be able to answer them all more or less, and we can forgive you maybe the occasional omission, but you should be able to answer them. And what I think we see from something like GPT-3 is no, there's no robustness there. And so it's this pattern, recurrent pattern of, you get a little bit further away from a specific training example and it breaks that really matters. So back to my thesis for a second, lots of systems could make over-regularizations. So there was a long literature before Rumelhart and McClellan's great paper in 1986. There was a lot of work on children's over-regularization errors. Someone before me had done their whole thesis on it, and it was a large part of my thesis. So this is when kids say things like braked and goed and stuff and so forth. And the received wisdom, which I think actually turns out to be true, is that children are applying a rule to a stem of a verb where they don't know the past tense form. And there's some subtlety there we don't have to go into. But so one version of the theory is they have a rule, add ed and get the past tense of a verb. So add ed to go, you get goed instead of went. And what Rumelhart and McClellan showed quite correctly was that was not a logical truth, that you could get those errors from an analogical mechanism in a very simple neural network that today we would think of as trivial, but it was a simple neural network, and it was able to produce these errors on occasion. Turned out that empirically there were all kinds of problems, and that's really what part of my thesis was about. My first publication was about is the SRCD monograph, Overregularization and Language Acquisition, if anybody wants to look it up. And we showed that empirically it relied on changes in input statistics in order to get the curve that it got, and those weren't plausible, and all kinds of empirical problems. But the theoretical point that Rumelhart and McClellan made was right, that you could get this error in multiple different ways. And so, ironically, the error was used as the evidence of intelligence, right? It was the fact that kids made it either showed that they could use rules and that was intelligence, or that they could use the form of intelligence body in neural networks. But they are the analysis of the error. And the real question is, do you have the right account of why these errors exist? And ultimately, the GPT-3 bloviator paper that should be called GPT-3 Bullshit Artist is making a hypothesis about why you get these errors. And if I had infinite time, I would try to pursue that and try to show over some range of cases. And you really need to know the input corpus to do this right, and they have not shared it. But if you knew the input corpus, then you could ask a question about generalization. You could say, as I extend beyond the input corpus, how good is the system going to be? And I would make the prediction that for you, as I vary beverages, you're still going to understand that they can all, we could get some corner cases, but if I have a glass and I break the glass, that the beverage is going to fall out. Right. And you could do that for a wide range. And I would make the prediction that GPT-3 is going to be really bound by its input corpus. That's exactly the argument that we made in my 1992 paper. It was that children would make these generalizations without respect to similarity, that they had learned an abstract rule and they would do it in general. So after 30 years, I've done nothing that I didn't do in my thesis. I think that's the lesson from that. So exactly the same form of argument held there, right? And we couldn't make the argument perfectly with GPT-3, but the prediction is that as we get far from the corpus, the system is going to fall apart. Now, embeddings are interesting in this regard. They can do synonymy in really interesting ways, but I would still hold with the spirit of that prediction. that you move away from the corpus, and the abstraction that you need is not really there, that there is not really a strong notion of a container or a person or any of that stuff, and that move from the corpus and it's not there. One error is not going to show you that. And so
Gary,
the article's
thank
not
you.
perfect.
So yeah, I mean, so in other words, if I understand it, it's not like people are ganging up on AI whenever it makes an error, but humans are allowed to. It's the nature of the errors and what they mean that matters, right?
That's what
So in other
ultimately
words,
most revealing. I
yeah,
won't say
right.
people don't gang up. I mean, people who follow me on Twitter love these things. That's why they follow me, is to be amused when the Tesla runs in, thinks that two circles on a street sign are a stop sign. And there is a set of lovers and a set of haters, and I tend to draw the haters, I suppose.
Okay, so
you really want to know is, why is that error there? What does it tell me about the underlying machine?
Right. So Chaz, is that okay? We were going to invite somebody else in. Did you have a rejoinder?
Yeah. Oh, yeah. If a follow-up is permitted, I would just add that it's my sense that the people who that none of the errors that are discovered in this way are that surprising to the creators of GPT-3. It's never been my sense that, Gary, you show one of these things and then someone at OpenAI says, "Oh my God, I can't believe it made that mistake. I'm so surprised by that." It's more just what's read into it. My sense would be that your interpretation of the mechanism that produces the errors is the very same interpretation as the ones that the OpenAI people have for what produces the errors, and that where you differ ends up being on whether that should be embarrassing for the model. And I guess but there's more to say.
I think the GPT-3 paper. I think the GPT-3 paper was much more careful than the GPT-2 paper. The GPT-2 paper really invited inference about a level of understanding that was not in the system. By the time they wrote the GPT-3 paper, they were much more cautious. They acknowledged physical errors. They didn't acknowledge psychological errors, but they were at least, they become hip to the problem, let's say. And I think that paper was reasonable. I think that some of the media campaign stuff that they have done has been problematic. And I think that they have shaped the public interpretation by doing things like sharing the model with journalists and not with people like me. And I think that they played some games after the fact there.
That seems right to me. Thanks.
Thank you,
Chaz. Was it Ida? Was it Laurelyn that was going to be invited in, and then Brad was going to say something? Is that the order?
Yeah, Laurelyn and Brad is going to read. So Laurelyn had a question right now, and then Brad was going to read the question from Black Women in AI. So Brad, why don't you go ahead and read the question while we wait for Laurelyn to join on stage?
Sure. I feel very unqualified to recreate the perspective of Black women in AI, but I'll do my best. So their question is whether the collection of data is used to confirm what we already believe, right? And there's a lot of, there's been a lot of examples of this, of big data sets that basically take us down a pathway of reinforcing existing biases. And I guess the sort of caveat that I would add to that question is, that clearly, to me, at least seems to be true. What is it about the human mind? I mean, we have confirmation bias, but what factors exist in the human mind that sort of protect us to some degree against that same kind of fallacy?
I think there's a couple things there. So one is, the people that collect the data, some of them have good intentions and some of them don't. And some of them are more careful about these things than others. And it's hard to draw a broad brush across them. There are cases like Amazon tried to make a job interview system, and I think they did it with good intentions, and they couldn't get rid of the bias using existing machinery. So they didn't want to have bias in their system, but they were stuck with it. The reason they're stuck with it is taking me to the second part of the question is the systems that we have now basically are so dumb that all they can do is perpetuate history. They don't understand the difference between, let's say, history and values. So you might find historically in your data set, for example, that ballerinas have not been very good computer programmers, or there haven't been any good computer programmers who were ballerinas, because historically there haven't been any ballerinas because the opportunity was denied to them. I'm not saying that's still the case, but if you had a historical data set, you might, reach that conclusion. Hello there. And these systems, all that they do essentially is to take the historical data and move it forward. So if you had looked at musicians in orchestras, I can't compete with that. I didn't mean that 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 our guests should leave the crowd. I mean, there's data to be collected there. Hello there. So if you looked at historical data about women in orchestras and you're in 1910, you say, well, correlations here or whatever, my deep learning system says that women can't be in orchestras, right? It's, the data are there. What you really want to be able to add is some representation of what you're actually trying to achieve. So you want to be able to reason about things like opportunity. Why is it that up to some point, there weren't a lot of ballerinas that were programmers? And is that something that we want to make as a causal mechanism? Well, no, but you have to be able to reason causally about these abstractions. And we're not very good at it with the current AI. So another example I like that's on a slightly different point, but I think is of the piece with this is Asimov's laws start with your robots shouldn't do harm to people. And that sounds all well and good, but we don't know how to program what a harm is, right? If you can't program what a harm is, then you can't really deal with the bias problem, because bias is a form of harm, right? And so the paradigm where you show pictures and labels works great for labeling that, this is a phone or something like that. It doesn't work very well for abstract things that are not represented easily by concrete nouns. And the notion of justice or equality or opportunity or any of those things, they don't fit into the label, supervised training regime. We're going to need systems that can deal with more sophisticated abstraction to really solve those problems. In the meantime, we have Band-Aids. So we notice the gorillas and African Americans thing in Google, and that gets patched up. But then, you do a Google search, maybe this will still work, maybe it won't because they get patched up. But grandmother and granddaughter, and you only find white people or something like that. There's just an endless array of long tail cases that cannot be handled by just band-aiding statistically a little bit of data representativeness and stuff like that. You really need to be able to reason over what you're trying to accomplish to really solve those problems. And that's going to require deeper level of AI than we have. It's not impossible. I haven't said that all night. In no way do I think that any of this is impossible. I just think that we need to reframe how we're thinking about some of the problems to make progress there.
Brad, do you want to ask your own question too, now that you're up here?
Sure, yeah, I'd love it. You have an answer to this one, which is, you mentioned earlier burying the hatchet right between these different camps. And I guess one of the questions I had was more about education, which is, do you think that one of the issues that persists is that people genuinely don't understand how we, when we talk about implementing symbols in AI, right, we're talking ultimately about, at least in the brain, a neural implementation of symbols. Do you think people sort of fundamentally misunderstand the idea that we can implement symbols in some kind of neural architecture?
I honestly don't know where the hostility to symbols comes from. I think in Hinton's case, his, not in a general case, but that particular person, and I think he's the most hostile to symbols right now. It comes from the history of these debates and how resources were distributed. There may be a little bit of historical thing because his great-great-grandfather was the guy for symbols. And he kind of wants to show that he's got his own thing. It's an interesting historical footnote. The Laws of Thought was by, I think it's his great-great-grandfather, but I could be slightly off. And so he wants his own paradigm. I think that lots of other people resist symbols because it sounds like it implies that the brain is a computer, and people don't like that idea fundamentally. And so it feels disgusting to people, sense of ooh, get that away from me. And so people don't want it. I think that there is another kind of input into this, which is that there are a lot of people who want to do things that are biologically plausible and don't recognize the difference between mechanisms that are tested by biology and mechanisms that may exist but haven't been identified yet. To my mind, this is exemplified by Jeff Hawkins, who has done very good work trying to realize what is known about the brain in systems, but there are lots of things that aren't known about the brain, and I think they get a short shrift if you take that maxim too seriously. So we don't know, for example, how zero trial, or however you want it, write once memory works in the brain. I'm absolutely sure it exists. If I tell you now, I must go in 25 minutes, you can remember that. I don't need to tell it to you 100,000 times. I don't know how your brain does that. I don't know how it parses the sentence. I don't know how it encodes on one trial in such a way that that can make a causal difference, and at 3:59 will say thank you very much to the speaker. We don't know that mechanism, and some people are like, if I don't see it in what I know about neuroscience in 2020, it must not be there, which is a very fallacious argument, but I've seen any number of people make that over and over and over again. And then the flip side of it is, like, if you do know something about the brain, why are you taking any of this seriously, right? Like, there are 500 different proteins in a synapse, and there's 1,000 different neuron types, and you're looking at these systems that have basically one neuron type that conflates excitation and inhibition and nothing about the rest of the architecture, and you're like, this is brain plausible, this is biologically plausible. And so, like, the argument seems to me to be ridiculous, but those are some of the reasons, or the historical roots to it. And money, there's so much money in certain sides right now that people don't want to share the resources. Yes, the Boole Hinton family is amazing, despite my reservations.
Well, thanks, that was very educational.
Thank you, Brad. Laurelyn, go ahead, and Jovo will be inviting Martin while Laurelyn is asking her question.
So hi, so my question is a little lower level, but it links very well with things.
Sorry, one second. Yeah. If you could introduce yourself, because I don't think Gary knows you.
I do not.
So I'm a postdoc working at Columbia University in the Theory Center. I do theoretical neuroscience. So my question is a little lower level and linked to some things that you just talked about. So it's kind of nice. Like, I was wondering, often when I'm hearing about adding priors or adding structure to RNNs in the context of, or artificial networks in general, a lot of time people focus on high-level skills, compositionality, language, and I think that there's a lot to be done maybe from the psychological literature there in terms of algorithm maybe. But in terms of neuroscience, as you mentioned, we're just not there, I would say. But I think that there's really like a lot of exciting work in vision, in motor control, and like a lot of very flexible behaviors. We do start to know a lot about their network structure. And so I'm wondering whether you're thinking that there's a little bit too much of an emphasis on trying to include architectural constraints at a high level and less emphasis on maybe more promising avenues where we have more to offer.
It's a good question that made me rethink how I presented the talk. It made me think of a different way I could have presented it, although it would have taken work, energy that I didn't quite have. There's a kind of translation problem, I think, right now that has not been solved in either neuroscience or AI, which is, how do you take some high-level knowledge and map it on to the stuff that we assume the lower-level things are doing? So those lower levels could be physical neurons, or they could be nodes in neural networks. So I'll give you an example, both of where it works well and where it doesn't work well. So the best thing that has been translated, to my knowledge, is translational invariance, that an object is, has the same appearance in different places. That is convolution. It has been translated in a very neat way down into something that a neural network can do. And that is awesome. And most of the progress in the last decade or so has basically been because of that one realization about translation. And maybe I'm not reconstructing the history right, but the translation of it, whether it was explicit or not, I think it was partly. You can look at LeCun's '89 paper. It's even a little bit longer. Has been amazing. It allows us to do all of this kind of stuff in image space, for example, and auditory space. And it allows us to do that because those spaces are orderly, and so it's a great prior. But here's another prior, which is objects persist in time even when you can't see them anymore. So, my hand goes off stage, but you assume that it's still there, or I have this, and my hand goes behind my phone and comes back out. How do you realize that in the kind of architectures that we've been playing around with in these two fields for the last several years? Nobody knows how to do that. We don't have a good system of translating that. I would argue that to do this one, the minimum that you need is some kind of record keeping system that says this is an object at this location over this time. And we don't really know how to do that. There's some cognitive psychology work on object files that Ann Treisman and Danny Kahneman did that is relevant. It might be in the hippocampus, but I don't think we know how it works. And in the neural network side of things, people have been very resistant to having records that look like symbolic computer science-y stuff. Now, this paper that I saw by one of Bengio's students is actually coming close to that. And I think that that's an advance to be able to do that, to say, look, we actually need the records and we're going to track the records. I think that's a step towards, you call it neurosymbolic stuff. And as you start to have those kinds of representations, you might have a better shot at representing the persistence of objects. But you can't represent the persistence of objects if you can't represent individual objects as being enduring with properties. And if you're just doing like deep reinforcement learning from pixels to action, you're not doing that. And so, we need to solve that translation problem in order to take observations from psychology, for example, and import them. There's some exceptions to that. Like there's certain things people are doing in kind of under the umbrella of neuroeconomics with certain very narrowly construed decisions where it's easy to make that mapping. But in large part, we don't know how to make those mappings yet. I love the live the live linking there. It's awesome.
Yeah, well, it so happens that I'm working with Anirudh Goyal, the first author, and Yoshua Bengio on a follow-up on these kinds of work. So I'm glad that you mentioned it.
That's right, you're an author on the paper.
I'm not. No, I'm currently collaborating on a future thing. I'm not an author on the paper.
Okay. It's literally on the top of my stack. I only read the abstract. I haven't read the paper yet. So.
It's pretty good, and it has a couple of follow-up papers, a series of papers at ICML, and iClaire got inspired by it, so it would be fun too.
I think it's good stuff.
Yeah, thanks. Just maybe as a remark, I think maybe part of the translation issue is that currently the field is so concerned with like beating a particular, benchmark on a task that is chosen not to be flexible, that it can be hard to just, express yourself.
I promised, I threatened a brief remark on the Turing test, and this is a good segue into it. I think a lot of benchmarks have problems, and it actually relates to the question I was talking to Chaz about too, which is you can get lots of different behaviors for lots of different reasons. What we want the field to do, these fields to do, I think, is to move towards an intermediate level understanding of primitives and how they work together. That's what the Atoms of Neural Computation paper was about. And if you focus on these high level behaviors, you often wind up gaming the system. So for example, what's happened with the Turing test, it was a good idea for 1950, but what it really does is it encourages you to evade things. So the way you win is you pretend you're a 14-year-old boy from Odessa who doesn't speak much English and wouldn't answer the question if he could. And then, the sort of paranoia holds the day. And you're not actually getting at, does this agent that I'm talking to understand how the world works, unless you're a sophisticated interlocutor of that system. And so it doesn't tell us that much. And all of this benchmark pursuit, in general leads to people like finding statistics that are correlated with particular things, but not to answering questions like, if I really wanted to represent the affordance of an object, what would I do? I think that this is a place where the incentive structure in the field has actually done harm. It's moved people away from thinking about questions that they actually thought about more in the 70s and early 80s about like, what is the right knowledge representation here? Like, I think we still need to answer those questions, but they're slow and painstaking, and it's a whole lot easier to like have a bigger data set and say, look, I do better on this benchmark.
All right, so next we have Martin. Well, he disconnected again. Maybe invite also Zena and Martin, both of them, so at least, okay, and he's upside down, but that's great.
Dude, what have you done with gravity? That is so cool.
All right, go ahead.
All right, can you hear me at least?
Yes.
Okay, awesome.
And you've descended to the earth.
Yeah. Sorry for those confusions. So my question is mostly around the examples you gave for language. So you gave several examples where GPT fails in responses to produce the right kinds of responses to the queries. And most of the argument was that GPT lacks the kind of world knowledge that's required to respond in the way that we want it to respond. But why do we even expect GPT to have broad knowledge of biology, psychology, and so forth when it's only trained to produce things that look like sentences? And maybe relatedly, it seems that the brain's language system is also not thought to contain all that knowledge. It's just processes language. In fact, there seems to be a pretty strong correspondence between GPT's representations and the recordings of human language processing. So it seems that a lot of what you're assigning to language is less sort of language processing, but more like high-level reasoning, planning, and so forth. And so I'm wondering if you're like, if you make a distinction between language processing and language understanding, or if not, then why do you put them together, I guess?
Sure. I'll start by referring you to a paper by Emily Bender. Maybe we can get up on the thing, and the co-author, I can't remember, that's about basically meaning and in GPT-2. I think that there are two questions you're asking. One is it reasonable to even expect GPT to have a lot of world knowledge? That was your term, not mine. Mine is really about theories of the world. So intuitive physics, intuitive psychology, and so forth. And at some level, I don't think it is reasonable. I think that the problem lies in people mistaking this system for being intelligent. And so, you can look at how people write in the lay literature. If you actually look at what it does, it's obvious that all it does is predict the next word. And it's not going to be able to do any of those things. And in order to debunk the notion that it is sort of advanced towards general intelligence, which I've seen a number of people write, you have to sort of push on those kinds of levers. Syntactically, and then I'll come back to the Bender paper. I think that's the paper. Thank you. Syntactically, it's well formed. It's astonishing how grammatical its output is. But semantically, it's nil. It does not have a representation of the things that it's talking about. And one way that you can do it is by playing the kinds of games that I've played with it, or you can do these various kinds of experiments. The reality is it is not doing what language I think is really about, which is mapping between meanings of sentences and their structures. That's really what language is about. I hear a sentence, I infer a meaning. And in fact, I combine that with my world knowledge. So you can't really do language without world knowledge because we mostly don't express most of what we mean. So language is deeply underspecified. We leave out a lot and allow the reader or the listener or the viewer or whatever to infer most of what's going on. If I explain absolutely everything at every step, you would be bored out of your mind. So like any written text is going to leave out a lot of what's interesting. In order to recover the meaning, you have to take the literal meaning of a sentence, and then you have to combine it with your prior knowledge about the world. So you have to know that people are alive, for a certain number of years, and then they die, that they breathe, that they need food, and all that stuff's not going to be spelled out, but you need to use it typically to infer what somebody might say about something. But language is ultimately this mapping between, in one direction, you hear a sentence, you infer what the listener is trying to tell you by a combination of mapping the syntax onto semantics and then applying your pragmatic understanding of the world. That's one version of language, which GPT does not engage in. And the other is to go in the other direction. So I have an intention that I want to communicate with you. I will not spell out certain things because I don't want to waste your time, but I will force it into this low bandwidth communication system where we use a bunch of squeaks over time, or we could do sign language. I can't really do sign language, to indicate, meaning, right? So we're mapping it onto this linear string. It just doesn't do those things. So then that raises a question of, if you want to illustrate that rhetorically to people who don't understand what language is about, what do you do? So you wind up interacting with it. And, the terms are sort of set by the system. The system, what it does is predict the next word, and that's all you can do to interact with it. And so there's something where, in a certain sense, I'm cooking the books because the books have already been cooked. And there's kind of no other way to illustrate the point. To somebody who, like Bender, who does language for a living, you don't need the demonstrations. It's apparent when you look at the nature of the architecture that it's just not really engaging in the right question. But how do you illustrate that to somebody else?
Maybe if I can follow up on that. So,
sorry, very quickly, because we have a bunch of people.
I'll try. Yeah, this is longer. I'll leave it to others. Thank you.
Thanks, Martin.
Thank you, Martin.
We're in the lightning round now. Quick questions, quick answers.
I think you have a hard stop in 11 minutes. Is that true? Yeah.
Yep.
So maybe you can invite Megan while Zena is asking her question.
Hey, I'm Zeno. I'm a postdoc at MIT. Can you hear me okay?
Yep.
Cool. So I had two questions, but since the time is short, I'll just ask one. And that's really just to give a more charitable interpretation of the kind of the pure learner or the pure deep learning perspective. It seems like they're saying a couple of things. One thing is that of all the things that you had in your list, you know, causality, objects, semantics, we don't know very much about these things. We know some things, but there's many things that we don't know. And I think the risk that they're worried about is that if we encode false things into our models, they're going to, you know, give us false results. And the second thing I would say, again, a charitable perspective, because for the most part I'm on your side of things, is that this distinction between, you know, what's innate and what's not becomes somewhat less important from their perspective if you have to learn the system from scratch. And so I've heard people like Demis Hassabis say that we're not modeling a child, we're modeling the whole of evolution, right? From the beginning. And so from that perspective, it doesn't really matter what we choose to have as innate or not innate. And so I guess my main question, and especially on the first part, would be how should we build systems which simultaneously do encode these high-level structures that you spoke about, but also are not constrained in such a way that we've encoded false beliefs or false knowledge that the system cannot escape out of?
So I guess there were a couple questions there ultimately. On the second question, what I would say is ultimately this is an empirical question for AI. They're not for neuroscience, or not in the same way. So neuroscience, there's some fact of the matter about what stuff is innate. We'll eventually figure it out. We can't entirely answer pre-theoretically what would work for AI, but you got 1 billion years of evolution that you're trying to reconstruct. And my contention would be that there's a good chance you might learn something from doing some reverse engineering on that. I am not saying that, and this is something I should have clarified before, that the right AI system is going to be exactly like people. So for example, that was the book Kludge of mine that was mentioned, is all about things people do badly. I would not want my AI systems to have confirmation bias, to participate in motivated reasoning, to have bad memories, etc. Right? I mean, I hope that we'll eventually build intelligent agents that lack all of these things that make us so hostile to one another, and instead have systems that are more rational, but also have the flexibility of human cognition. And the thesis here that I didn't state is that we could learn something about doing those things by looking at how humans do it, or other animals, to Jovo's point earlier. So object permanence is something that I think is pretty widespread across the animal kingdom, in fact. And if we can figure out how any animals do that well, maybe we could figure out a better way to encode it in our systems. To your point about false knowledge, I'm not so worried about that problem. If we do the knowledge in a way in which you have individual chunks that you can evaluate, you can just get rid of the ones that don't work. If everything is hardwired in the way that convolution is, maybe that's hard, but I'm not so worried about it. I think we can put weights on bits of knowledge and do consistency checking and so forth, and that we're better off having some bootstrapping system that we can evaluate than just trying to do this like deep reinforcement or GPT thing over and over again. I think we're running into walls on that. It's just not really working. People can place their bets elsewhere, but I'm advising them not, in part because I think that that's putting them in the position of having to reconstruct 1 billion years of evolution every time they go out the gate. And that seems foolish to me. Every time you go out there, you're going to have to relearn object permanence. You're going to have to relearn that there are places, that there are trajectories and so forth. That just seems silly to me. I mean, why not put in the hard work? I mean, it's like, in principle, you could learn a browser, right? You could have input logs and see what the browser displayed and learn it from data. Like there's this canard that, oh, we're going to replace computer programmers with machine learning. I think that's ridiculous. Nobody's ever going to build a browser that way. It's much better to start with some notions like what a web page is, what a link is, etc. And then maybe you could learn some stuff around the margins, like how to more efficiently compress these kinds of pages. But knowing that stuff, to relearn that every time from browser logs would be insanity. I don't think you get a follow-up if we're going to do the speed round. I think we get one last question.
I'm just saying thanks.
Thank you. I didn't say you were. Thanks for your question.
Hello, Megan. Please go ahead and maybe introduce yourself very briefly for everyone who hasn't met you yet.
Sure. Yeah. Thanks. And I'll try to go fast. So thank you for the great talk, Gary. My name is Megan Peters. I'm an assistant professor in Cog Sci at UC Irvine, and I work on metacognition and consciousness and perceptual decision making in humans, primarily, and do some neuroimaging and computational modeling. So this was a great talk, and I wanted to maybe this is good. We can end on a little bit of a high note, like forward thinking. Maybe we'll see, which is we talked a lot about the need for the capacity for compositionality, the capacity for recursive thinking, the capacity for all of these things that current AI is just really terribly bad at. And I was wondering if you might kind of hypothesize about what current tools we have in AI that would give us the substrate that is necessary for developing these things. So it's not so much that we can say, I want to like just build compositionality into AI and I like know how to do that, or I just want to build recursive representational capacity into AI and I know how to do that. We've only got a certain set of very kind of basic tools right now. We've got convolution, we've got meta learning, sort of, we've got, you know, some of these other kinds of things. So of the tools that we have available, would you mind telling us which you think might be the most promising in not only developing the capacity for compositionality, recursive representation, et cetera, but for building that substrate, that, you know, genetic substrate that we talked about maybe an hour ago, that leads us to the ability to have this? Do we even know how far we have to go, basically? And do we have an idea of how to get there at all?
Well, you promised an upper, and I'll start with a downer, which is no, we don't know. Okay. And there might be some things cards I want to keep close to my vest, but you know, since I'm running a commercial enterprise in my not free time. However, I'll frame it this way: things like recursion and compositionality are not mysteries. Classical AI does this stuff all the time. You know, General Problem Solver, the original GPS, I think could do Tower of Hanoi, or certainly lots of systems in that ilk could do it. It's, you know, people know how to build, although they don't know how to get wide coverage, how to build parsers that have, you know, rich compositional semantics and so forth. The real issue, I think, I called translation before, and I'll call bridging now, just to give it a different way of thinking, right? We don't have good ways of making these systems compatible. Now, there is a section in my Next Decade in AI article where I cite about 20 hybrid architectures that people are working on. I think all of those are hints. I think there's some discoveries yet to be made. And I think it also depends on the problem that you're trying to solve. So if you take seriously what I'm saying, the issue for neuroscience is like, how do we represent that symbolic knowledge at all? And the issue for AI is, in any given problem that we want to solve, like guiding a robot or guiding, well, I was going to say driverless car is a robot, you know, domestic robot or a driverless car or something like that. It's really like, how do we want to take these different tools and put them together? And I think that means building better bridges, and it also means reflecting on the art of picking the right tool for the job. So, you know, a good carpenter knows when you use a hammer and when you use a plane and when you use a saw and so forth. And I think we need an increased sensitivity to, there's actually a lot of existing tools that will do certain things, but if we're trying to like do something end to end, we're forsaking all those other tools. So what is the right way to put them all together? So, I mean, without giving you too much detail, the philosophy we're taking at Robust is it's fine to use all kinds of stuff that other people have used before. And a lot of the art is in picking the right tools for the right jobs and not being doctrinaire about it. So I think we promised a t-shirt where I said something like, in the course of a meeting, you know, deep learning is not bad for that problem. And so people thought it'd be funny to put it on a shirt. You know, we're actually totally open to using it in the problems that it might be appropriate for. And we're totally open to using, you know, classical planners if they help us in certain places, or, you know. And so it comes back to the eclecticism or the open-mindedness and so forth, that part of it is just like using the existing tools better than we have. And part of it is building bridges so that you can translate between these different systems as you need. And I'll maybe leave with one last thought before I go, which is the Kahneman stuff about system 1 and system 2, which in Kluge, I call the reflexive and deliberative systems. You know, those two systems talk to each other. They're not perfect, But sometimes we get the best results by having them talk to each other. Like Peter Golitzer's stuff, which I mentioned at the end of Kluge about implementation intentions, is an example of taking a system 2 desire to stop eating chocolate cake all the time and translate it into something that the reflexive system can actually work with. So that's, you got both systems there, but it's finding a new way to get them to communicate with each other so that you can get the system 2 to be part of the equation. I do have to go. This was a real pleasure. I don't know if it's possible to get the transcript and the questions, but I certainly enjoyed all of this. I thank you very much.
Thank you, Gary.
Thank you
That
so
was
much,
really
Gary.
wonderful.
It's been a fantastic session.
Bye-bye.
Take care. Ciao.
Thank
Bye.
you. All right, everyone. Thank you for enduring with us until 7 p.m. We keep getting later and later.
Well,
every
we
time.
started a bit later this time.
It's
right?
true. We started at 5. Yeah, next week it's going to be at 4 again. So,
Okay.
when we have West Coast guests, usually it gets a little later. Last week also it got a little later.
Who is next week? I shouldn't be asking. I should know, but I can't remember. Who is it?
Is it Jess?
I think it is Jess next week. What's today?
Yeah, it is Jess next week.
Next week. Jess Hamrick.
We have Jess Hamrick next week. Yeah, that's right.
Excellent, Jess.
Which is exciting. Thank you. And yeah, thank you, Megan, for that great question. And also just something that I want to add. He mentioned implementation intentions. I'm very happy somebody mentioned that. My PhD work was on prospective memory and how we decoded that, which is having an intention to do something else while you're doing something else. And implementation intentions is sometimes defined as this idea of writing down 3 times before you want to do something, that when I see X, I will do Y. When I see X, I will do Y. When I see X. So it's basically reinforcing your prospective memory using an episodic memory strategy. The idea is like, if I wanted to tell myself all the time, I'm going to do X, I'm going to do Y, I'm going to do Y, then my working memory will be jammed and I can't do other things. But if I totally rely on my episodic strategy that when I see X, it's going to automatically, spontaneously in a bottom-up way activate my thing, it's not reliable. So a combination of that, so prospective memory is this combination of the two, and I've done some work on it. We did a rational model of it with John Cohen and Ken Norman of how working memory and episodic memory combine for this. And it was fun that he mentioned implementation intentions, because that's the case where you're using both of the strategies so that you prime your episodic memory to be more accessible from the beginning. So you're managing before something happens how much your bottom-up system is going to be activated. So I'm very glad someone in this salon mentioned that. It's very sort of yeah, I think it's as high level as your work, Megan, which I'm glad that you are here to represent also.
Megan, Zena, you're here. You have the bully pulpit. Anything else you want to bring up while you're in here?
Well, I did have one thing that I wanted to ask to Gary, unfortunately, before he left. So maybe I have to go as well. But maybe I'll just leave with this comment.
We'll just simulate him.
So Gary said that we can use kind of these existing toolkits we can start there at least by using existing toolkits and by putting them together in novel ways and getting them to talk to each other in novel ways that maybe will make progress on deriving or discovering or implementing the substrate that can lead us to true capacity for compositionality and representations that are recursive and so on. But I'm not sure that feels like enough to me. It feels like we can't, knowing which tool could potentially be applicable for the job doesn't feel like enough. It feels like you have to know how that tool works in order to understand how it works with other tools. So knowing that I have a nail and I need to hammer it, and I know that I need to pick up the hammer to hammer the nail doesn't feel like just knowing the hammer is the right tool is enough. And so I think that there's this gap between knowing which tool is applicable for the job and understanding actually something like the I don't even know how to put this, the way that it works, the language that it speaks in some way that would be required in order to actually learn how to put the tools together. So you can't just like put them in a bag and hope that they work. You have to understand how they work together in a very deeper way. And I don't know if just applying the tools that we have in their current forms will actually get us there.
So just having the capacity for compositionality is not sufficient. You need to be trained how to use it depending on what are the tools. I think that's a great point. It definitely goes back to the question I was asking Gary about what is it that is like civilization shot? Like we learn it when we are very young because we've learned how to use these things and people assume it's innate, but actually it's not. I think it's very related to that.
Yeah, it's like
I also think.
Go ahead.
Wait, let Megan go. Let Megan go, John. Megan, go on.
It was really just about how, like, if we have this, genetic substrate that allows for symbolic representation, symbolic manipulation, compositionality, whatever, we just knowing that the substrate does that doesn't give us how it does that, and the how is what's important. And that I think we're still missing, even if we discover which tool is the right one for the job. And I don't know how we're going to get there, but that feels like that link is the drive that we need, or the thing that we need to drive towards.
I think what you were saying is that you need compositionality. Understanding, having a conversation like we're having about compositionality isn't just compositionality, right? In other words, there's something extra that's allowing us to talk about compositionality, and we don't really. What is that extra, right?
Yeah.
And so even if, as you say, we had the tools for beginning with compositionality, what's this meta thing that has us worrying about it?
Yeah.
Right. And it can't be the same thing, right? So it does feel a bit infinite regressy, right?
Right. And even, even in the same way that just building recursive capacity into a machine doesn't give it the ability to use that recursive capacity in a way that will give rise to all of these other things that we want it to do. Like you could build it, just as Gary was saying, you can build a thing that does a Tower of Hanoi problem. That doesn't mean it can understand how to use that tool to do something else that we would need it to do to look intelligent in any sort of AGI sense. So I was kind of hoping maybe he would go there, but maybe he's holding that close to his chest for corporate reasons. I'm not sure, but maybe we can follow up on it, afterwards. That would be nice. So I do need to run off, but I appreciate the opportunity to kind of ramble a little bit. Thank you for putting this together. And
hope to see you in the next weeks too.
Yeah, that'd be good. Thanks, guys. Bye.
Bye. Zena, any famous last words?
Yeah, I feel like, people were nice today to Gary Marcus. John, you weren't your normal antagonistic self.
Well, because I wasn't my antagonist self, because I agree with almost everything that he was saying. I mean, it seems, it's sort of interesting that he can get people very upset because of his, he can be quite combative, even though in a sense, what he's doing is being a pluralistic counterbalance. In other words, I feel like it's more of a sort of, as I've said before, sort of a negative capability, which is, look, what about all these things that you seem to not be talking about, right? And then it gets to the other point he made, which is either we don't know how to do it and therefore let's not bother with it, or we explain it away and go, it's actually not really a thing, right? And I think it's that I find weird, and I believe that it is a thing and we are going to have to address it. And so I'm on his side most of the time, because I think that what he's pointing out is a thing that's lacking, and that's not much to disagree with, unless you're in the camp that just feels like it's an illusion, right? A Dennett-like notion that there's no such thing as qualia, that actually you're all deluded into thinking that there are these other things that are needed in a list. But either you're in the camp that believes in the list, or you're in the camp that doesn't believe in the list, and I believe in the list. Do you see what I mean? What's there to disagree with?
Yeah, I find myself trying to defend people who argue with him, which is funny because, as I said, for the most part, I'm pretty much on his side. But I think the way that they would characterize it as that they are being misrepresented, that they don't believe these extreme statements that they don't care about objects and they don't care about causality. It's just one, like I asked in the question, they don't want to limit themselves to wrong theories of causality or wrong theories of objects. I think he did kind of a little bit underestimate the difficulty with which it is to describe a theory of objects. Like, what is an object? It's a non-trivial thing. We really don't know a lot about objects, and so it's not as easy as just saying, okay, I'm going to build objects into my system, or I'm going to build object permanence into my system. We really don't know how to do that. I mean, there are some kind of new developments in this area, but it's a hard problem, and it has been for a very long time. So I agree. I think all of these things are important: causality, objects. I think one thing he didn't speak so much about is semantics. We spoke a little about this in the chat. Like, for me, the really hard part of compositional semantics is the semantics part. Like, what does mean in the first place, right? And so, but I think these are all extremely hard topics individually, and we don't really have any mechanism to just take them as they are and just kind of throw them into our machine learning or AI systems.
That's a very good point. I think that something that was interesting was that when asked to define, for instance, compositionality, when asked to define object, the answer was mostly, if you show me, I can say whether it is not. So I think that John is very correct in saying, so I agree with you that sometimes there's a straw man approach, but I think it's a rhetorical move for the purpose that John was describing. It's kind of I agree with you that it's less of perhaps a precise critique as opposed to maybe a caricaturesque kind of critique, just so that a negative space is created for questioning certain premises. So I agree with John that seems to be the operation, but I totally agree with your comment that, first of all, some sort of directions are missing. And one thing that we didn't get to, that maybe this might not be a bad time to mention it, Michael Chang mentioned, how do the object representations in deep learning-based object-centric world models, and he gave 2 references, compared to the variables and operations Gary is talking about, what is missing from current object-centric models? And I'm going to copy this and put it in the chat and just mention this too. So this was a question from Michael Chang. And so I agree that sadly we didn't get to that because I think the UK people slept early or they had to go to bed. I asked just so that she would ask this question. So it wasn't just, so it was also, I think it was Dan Baer who was also in the audience. I don't know if he's still there. And so in all of these cases, there is work in deep learning that relates to sort of object-centric world models, and it would have been fun to discuss that with them, actually. Brad says, I don't know, it's one thing. It's a lot of small things.
And also to get to your point, Ida, about you wanted him to define compositionality, define object. I mean, you know, in philosophy, they've long since given up on requiring, for example, a watertight definition of truth or a watertight definition of justice or watertight, I mean, that you can't proceed until you have that. And so I think what he's really saying is you just have to operationalize it and be a bit more local, because it's very difficult when it comes to these kind of ideas to shut them down to counterfactual attack, right? There's always going to be something that will bring down your definition. And so I'm somewhat sympathetic to not really being able to necessarily define things and be a little bit blurred.
So just to be clear, thank you for explaining philosophy to me. But actually, if you're doing AI, you need a mathematical you need to capture something minimally mathematically. You'll need to say, here's the minimal requirement or task or something that my equation has to do or my agent has to do in order for me to say this is capable of compositionality, right? And I think that it has a behavioral part, it has a representational part, and there are particular ways that you can approach this. You don't need a verbal philosophical definition of it in order to be able to identify what are the behaviors and what are the types of representations and processes underlying those behaviors that I minimally require to call something compositional. And that's the kind of answer that I was hoping to get, as opposed to a philosophical definition.
But would you? But he also made the point. Now, I thought you would actually answer back, Ida, when he said there's far too much mathematicalization as well. I mean, he said there's too much interest in mathematicalizing things, right? In other words, maybe you can't even come up with a mathematical definition that won't throw away some of the fuzziness.
He didn't say that.
No, but
And
he did.
he has an AI.
Well, he said something. I mean, maybe Jovi, where he said he said something like there's a little too much interest in the mathematics and a too little interest in the psychology. He said something like that.
I think I didn't hear that. Maybe motivated not hearing. But he runs AI startups that are trying to address these kinds of things. So the tools that we have when we are doing AI is indeed math tools. Even if you're patching, sort of Frankensteining different pieces of deep learning and you don't know what the total math is, at some point it's possible to analyze it to figure out what the math of that is. When we're studying representations and comparing representations in rodents, in humans, in theoretical neuroscience, we are using math at the end of the day. That's the language, that's the tool. It would be fun to have another tool, but the combination of specifying behaviors, specifying the underlying representations, or specifying a particular algorithm, or specifying a particular equation, there are so many different approaches to doing that if you are building a machine that is capable of having some capacity. And I think that that's what I was hoping to get. And I don't know what he would say, but I would be very surprised if he thinks we cannot mathematically capture compositionality.
So I don't know what he thinks. I have a poor Gary simulator, I think, but I'm basically sympathetic to what everyone's saying in the sense of course we would like to have compositionality in whatever AI things we build, because it enables you to be able to extrapolate in ways that if you don't have compositionality, it's much more difficult to. But I agree with John that it's not clear. I asked this question last week. I don't have a particularly coherent definition, mathematical or otherwise, that I can operationalize in AI. And it's not just me. I think there's lots of people who are working on it. And Jane recommended some articles last week that are on my stack now. But these things that Gary points out that are not in AI, they're not in AI, I think, as Zena said, because it's hard to put
Sorry,
them.
can you restate that sentence? You said you don't know how math can be used in AI. I didn't understand what you said.
No, the particular things that Gary is saying there's missing from AI, they're really hard to put in AI in a way that's really effective. That's why they're missing.
What was your comment about the math of them? Because you not having it, given you haven't studied them either in psychology or in sort of AI, is not a very high bar. So I'm wondering, what do you have in mind? What did you say about the math? What was the statement about the math?
I don't know.
Okay, thanks. Go on. Sorry to interrupt you. I was just wanting to make sure we don't I
don't mean to say it because I don't know it's not there. What I mean to say is it seems to be really hard to put these things into AI. And my evidence for it is that lots of people are saying that they're trying to do it now. And we're making progress, but it's not there yet.
Right. That's a general statement you made, not a, okay.
Yeah.
All right, so this is a rather low note to end on. Maybe we can do something that feels a little more hype and positive. John, do you want to give us a hopeful?
I don't think it was. I actually feel like I try to sort of, when I meta ask Gary, could we use this forum to bring these sides together? And I think that it's going to have that impact. I actually feel like, having one side, whether it's Jeff Hinton mocking Gary or Gary mocking Jan LeCun, I think it would be good, wouldn't you agree, if we moved away from that and had these kind of discussions? And as Megan said, what will the ingredients need to be to bridge this? I actually thought that was quite positive, actually.
Oh yeah, no, I just meant this last bit, but yeah, I agree with you.
No, I don't. I don't even think this last bit was so bad. I actually think you're probably, it's something that I don't have an intuition for, whether all the difficult things in the list, in order to be successfully incorporated into AI, will need a formalism. And I think you're probably right that it will probably be very difficult. How do you incorporate something into a machine if it can't be codified in some formal way? It must be true, right? So
we do study behavior.
Yeah,
sorry, go ahead.
It's just interesting. It comes back to what Zena and I were talking about, is I think Zeno said something like, we've got to distinguish between an algorithmic description of the tasks out in the world and an algorithmic description of how the brain is doing that. And even if there's such a difference between declarative and procedural knowledge, you're still going to have to do something on a regular basis inside your brain to do declarative knowledge things, right? And I suppose in the end, he'd probably agree with you that that process has to be capturable in some way in a formalism, right? I mean, isn't that? I mean, it must be true what Ida's saying at some level.
Thank you for some level, John.
No. But Jenna, would you agree with that? That in the end, it's going to have to be capturable?
Yeah, especially since we're doing experiments. Like we're defining it on the basis of work in psychology, on language, on object manipulation. It's the fact that, for instance, so I particularly have studied those things. That's why I don't feel like it's very far off or that it's not capturable. I think that Bengio's lab is doing a good job of reading through the history of psychology, looking into the 70s, something that Gary did mention with object files and schemata and trying to capture those. I think some people, like, as Matt Crosby said, the hope comes next week when we find out how AI is going to progress on all of this. So Jess has done beautiful work on, she does various things for tool use. There's people like the papers that Michael was referencing that have worked with capturing objects. I think there is like a lot of interesting progress, but making generalized statements like, oh, it's hard for AI because a lot of people working on it, I think I would be careful about that. I think it's good to get more precise. I think like having something like a panel where Gary's there, John Langford's there, like maybe Megan is there, maybe Jess is there to represent, or some other DeepMind representative. That kind of a thing might be fun that we do at some point, where we just like you were saying, John, if there is a conversation among a group of people that seem like they don't agree with each other, it might be better in terms of what we can learn from it and also what could be pushed forward. Because I do think that lack of precision and lack of doing the homework of reading what's been going on in the past 50 years in the psychology literature is something that happens sometimes easily, especially, in such a diverse and multidisciplinary field. And I think it would be very useful to bring people who are combining them. I think Jess is a very good example. All of her talks, she talks about the history of cognitive science. She goes and reads papers since the 70s also. She's another example of an AI person who's very sort of savant about the cognitive science history. So I think that we will have a lot of fun next week continuing this discussion. As I was mentioning to Zena in the chat, like this seems to be like a multi-episode discussion. It's not like a...
I don't, maybe...
What it ends up sounding... I was just going to say what it ends up sounding like is that in the limit, machine AI is the pathway to fully maturing mathematically the field of psychology, right? And I think that is extremely subversive and interesting to think that is, if you look at the history of science, there was a wonderful history of science published about 5 years ago that really gave a sort of mathematical account of the maturity of a scientific field, and it went through, and I think it's actually quite interesting what's hiding underneath what you're saying, Ida, is that the AI field is a way, and Josh and I have talked about this, of maturing the psychological field with the proper formalisms.
And cognitive science, yeah. So, it's not even a secret. Cognitive science has been doing it for like ever, right? The difference being that those of us who want to do the learning approach to it as opposed to the sort of classic AI and the probabilistic approaches, right? So, John, it's a good thing we're writing a paper together. We can put this in there.
Right, but because it's actually, because I think wouldn't it be interesting if it were true, right? In other words, that's actually what this is all about at heart. And I think that's really interesting. It's like AI is almost like another field that can actually rescue the other one, right, in a formalism. And that's your institute, right, Jovo? I mean, that's actually really deep.
Brad says many psychologists will not be thrilled with that. Yes, Brad,
no,
I have
I know that.
had so much pushback from anti-math psychologists. There are a lot of them who are just like anti-math in general. So I know what you're talking about, Brad, but...
Yeah, I'm not even sort of, I'm actually trying to sort of articulate a sort of not even necessarily latent, interesting meta assumption of a field. And I think that's really interesting. It may not be true, it may be disagreed with, but it's got a delicious ambition to it, right? I think that's really, really interesting.
On the point of meta, I think there is a kind of question as to whether the Gary Marcus approach to doing science is the right one, which is to say, let me introspect on things I think are important, and then kind of infer that these are the things I have to build in, right? And I think there's a big risk in taking that approach that one, you'll be wrong, as I've already said already, but two, you'll just miss many, many things, right? And so
Zen, I think that's really a little bit unfair. I think it comes down to whether you want to do empirical experimentation before you have a formalism and see what's out there in the world empirically and realize that we're not yet ready to fuse it into some kind of more formal structure. That's not introspection, that's the and it's actually interesting in the history of science whether one is not allowed to call experimental science, minus the same formalisms of theoretical science, any less thoughtful because it hasn't yet reached the formal stage. You can't just call it introspection because you're thinking fuzzily about empirical data.
Well, I mean, so if we take objects, for example, right? So I share the intuition that, you know, machine learning systems will do better if they have a system of objects. But I think it's quite hard to justify that from either first principles or from experimental data, right? So I think there is a kind of a principle by which Gary Marcus is approaching research, and I don't think it's like, you know, necessarily like the right one. I think it's probably the right one, right? At least in part. But I think the counter approach, the deep learning approach, they have a philosophical stance, which is let's just learn everything from data, right? As much as we can and make as few assumptions as we can. And so I think it's, to be fair to both sides, I think they both have kind of philosophical groundings, and it's not clear to me that one is much superior than the other.
Well, although in economics, the latter approach proved to be a complete disaster, right? In other words, you know, I would say that the people who relied more on quantitative empirical data in economics did a much better job than these very abstract models that couldn't predict a crash tomorrow, right? So in other words, you're right, but I think that empirical experiments and seeing children at the year one showing object permanence, that's an empirical fact,
yeah,
right? And you're going to need it in your life. I don't think that's loose. It's just an empirical fact, right? And how we actually incorporate it, who knows? But
there's a jump there. It is an empirical fact that, you know, young children and adults obviously, you know, have notions of objects. But there's a leap from that to say that we need to encode a system of objects into our AI systems, right? Those two things are not the same thing.
Yeah, I fully agree. And I would say, you know, there's other philosophical approaches too. And thankfully we were having Iris on the Salon in a few weeks, and she has a different philosophical approach, is more grounded in kind of like a cognitive psychological theory rather than Gary's and developmental psychology's community kind of organic perspective on what are the important things. And also different from the deep learning perspective of let's try to use as much data as possible and build in the inductive biases that we need in order to get the answers out. So they're all three, I think, have lots of value. And that's why we have this salon, is to bring everybody together. It's why Ida and other people organize a biological and artificial reinforcement learning. I'm guessing it's related to why she organized that workshop. And why, you know, John mentioned we have this planning institute to think about the interface between biological and artificial learning, which, you know, the salon is part of. So I think we're all on board that we need to talk more and figure it out together.
And I think it's funny that Brad is, you know, is saying, you know, but I think that I think the audacity that AI is potentially the path to a true theory of psychology is delicious, right? I think it's it's subversive, but I think it's what Ida's looking to pull off, and I think It's actually fascinating.
John, you're creating enemies for me by like exaggerating.
No. I remember our first discussion together. I don't think. I think it's really interesting, and I think Zena's point's a little bit different, which is maybe one can do without it and still do really well. I don't know.
So to be clear, I'm not saying like AI is needed for psychology. I'm saying it can help a lot of precision. So just let's not, hyperbole killed the cat, so to speak.
But Ida is a polymath, basically, right? Because she knows the psych literature and the AI formalism, so she can bridge them.
It brings a new meaning to the word polymath, right? Polymathematician.
A blue Jedi polymath.
Oh yeah, look, Jonathan's saying, John, well, if you read the goals from the first CogSci meeting at MIT, that was explicitly agenda. Yeah. Huh. Right.
That's what I'm saying. Yeah. And the whole point is, but they focus too much on the kind of particular kind of doing it. Some people are still doing it, so no offense, but some of us want the kind of a more. Oh, Jonathan, you're sending a lot of good references this time. Maybe at some point we should have Jonathan to talk to ask a question on screen. Yeah, the 6 pillars of CogSci. With that weird occult symbol connecting them. Oh my God, yes, that's right.
I'm going.
Yes, we are on that note. On the note of the occult symbol for the 6 pillars of cognitive science.
And Zena, we owe each other a call.
Yeah, let's do that.
Anybody else want to send a message to somebody else through this video?
Bye, everybody.
Bye, everyone.
Bye.
See you guys next week. Thank you.
Bye.
Thank you.